guys. How are you? Welcome to Dataverse. Yeah. So I'm Queenie. I'm partner of IOSG Ventures. So IOSG Ventures is a Web3 crypto native early stage fund, and we started in 2017. And we are one of the largest and earliest backers since 2017. Like we have like Polkadot, Cosmos, and Near in our portfolios, and also top DeFi projects like 0x, UMA, 1inch, and Liquidity. And more recently, we got like layer 2s like Arbitrum, Aztec, and Starkware. So you can see like infrastructure is our key focus. So today we initiated this Dataverse event because we've been paying a lot of attention to the data infrastructure for quite a long time and got several like very good portfolios here. And we want to accumulate people who are interested in data infrastructure to exchange ideas and also explore future or potential synergies together. So if you guys like today's event, please let me know. And I hope like we can do it every year and invite more people to join us together. Okay, then first I'll have Momir from IOSG Ventures to give us an opening keynote. Let's welcome Momir.
Hey guys, so first of all, thanks for coming. It's good to see you all. My name is Momir. I've been with IOSG for a bit longer than 2 years. So I joined just before DeFi summer, and I was very much interested in DeFi. So I was fortunate enough to lead some of the DeFi research and investment for IOSG. Also, I'm very passionate about data analytics, so from that angle, I'm also very excited to discuss this topic today. When it comes to IOSG, I think Queenie already introduced a little bit. I'll just add a few sentences to that. As she mentioned, like we started investing in the space in 2017. So we made like few big bets on like a couple layer ones like Polkadot and Near back then. But over the past 3 years, I would say we are mostly investing in Ethereum ecosystem, like more broadly. So we invested in everything from DeFi, we being like one of the early investors in 0x, 1inch, Synthetics, UMA, MakerDAO, and many other DeFi protocols. We've been exploring gaming space quite early. We invested in Illuvium and Big Time over there. Present also in the intersection of social and blockchain with the investment in Roll, with the investment in Project Galaxy, CyberConnect, investing in Ethereum native scaling solutions like Starknet, Arbitrum, Aztec, and obviously active in across the data stack. So I would say that IOSG is trying to back the founders that have like a long-term vision in this space, and it's also very nice to see some of you here that are in it for a long run. We are like geography agnostic. We have like portfolio across the globe, although we have like physical presence only in Asia. We are in this sense like a truly global company. So we invested actually most of the portfolio is in North America, but also have like portfolio in Australia, Europe, obviously Asia, and even South America. We invested one amazing team, POTS. I think they're also somewhere around here. So I would say geography agnostic, founder friendly, long-term oriented fund, and that would be kind of introduction about IOSG. So about the topic today, right, like Dataverse, so why data first, right? So I think that one of the key differences between Web 2 and Web 3 is the way we interact with data in Web 3, right? Like, so in Web 2, we have like these large corporations that control data for billions of people across the globe, and they have like exclusive right to utilize this data, manage it, distribute, like do whatever they want, right? Like even sometimes like they would use our data against us in a sense that they are building like powerful algorithms that define the way we consume content, like consume information, interact with each other. And these algorithms are often like optimizing engagement, like maximizing engagement, and also like trying to maximize addiction of the users, which is not necessarily like in the best interest of users. In Web3, on the other hand, like we have very transparent standards, right? Like everybody is able to query and analyze blockchain data. Okay, so everybody is able to query and analyze blockchain data. This means that so there is no more exclusive right to it. Like so, everybody can build on top of the data stack, and this by itself means that it opens up a lot of opportunities, right? Does it mean that now that data is like available for everyone, does it mean that it is valueless? Like, I don't think so, right? Even if you think in the most primitive form, like about raw data, it still requires like some level of technical sophistication, some like investment in the hardware to run the node, and obviously invest time that has like opportunity cost, right? So even in this like most primitive level, data has value, right? The more processing is performed on top of this data, the more valuable this data can become, right? So contextualizing this data is basically producing information that's valuable for many like stakeholders in the industry. So it's valuable for us as investment fund to try to understand like fundamental dynamics in the space. It's valuable for app developers to like assess whether they have product market fit or not. It's valuable for regulators, academia, right? And what I believe it's also going to be valuable for smart contracts in the future that will be more sensitive to the environment and like trying to read more on-chain data. I will address this like a bit more in the following slides. What else? Yeah, data in the Web3, it's also like our identity, right? Like whatever we do on-chain, it's going to define who we are like in this Web3 world. Like so eventually our access to certain communities, our access to certain products at like specific terms will be defined by like the data we generated on-chain. I think another interesting concept in Web3 regarding data is this like concept of user ownership. The best way to illustrate this on a very concrete example, I would think, would be like social graphs, right? And we will talk about that also in one of the following slides. Just a second. Right, so over here we kind of map the data stack as we see it like layer by layer. It looks like pretty, solid is there. It looks pretty developed, like already looks quite complex, but it's still relatively immature. I think like with the exponential growth of data generated like on-chain over the past 2 years, it became like a clear, like it was obvious to everyone that this is like a great opportunity that we have to like invest a lot in each layer of this data stack in order to sort of like create enough computing power, processing power, storage like room for like Web3 10 years from now, like, right? So right. So now a bit more specific, right? Like talking also about some of our portfolio companies. So here I would like to talk a bit more general at first, like about like on-chain data analytics and demand like for this like information, right? So in 2020, before 2020 actually, like I think this was not that obvious because only in 2020 we had like a first killer use case for blockchain, like which is DeFi, and then we started having like a lot of on-chain activity. Before that, crypto analytics was mostly focused on miner data, centralized exchange data, and prices, right? But now we have like a whole ocean of data that we can dive in like and like get data to like a very like tiny level of granularity, right? So everything is over there on chain. In 2020, with the DeFi summer, the total number of transactions on Ethereum increased 45% compared to 2019. Then in 2021, we had this multi-chain narrative, and BNB chain was one of the leading alternative layer ones at that time. So they had 8,000% increase in the amount of transactions generated. Today, we have more than 100 chains. According to DeFi Llama, there is more than 120 chains which are programmable and have some sort of ecosystem. So the space increased complexity by the order 10x, 100x, but we still didn't have we still have a gap to fill in terms of data analytics tool to enable us to process all this data. So I'm a big fan of Dune Analytics and also have quite some stars over there as a Dune wizard. But there are still some limitations, right? They're one of the best platforms for data analytics, but they cover only 6 chains out of 100 and something. There is still no clear direct monetization incentive for the curators on top of Dune. So there are obviously indirect ones, some people got their first job in crypto because of their Dune dashboards, right? Their Dune portfolio. Some people are getting grants. It's also a lot about social status in the space, getting these stars and becoming wizards and whatever. But there is no clear monetization in case that you create generate data table that's being queried a lot, or create dashboard that is the most popular on the Dune website. You won't monetize on it, right? Then there is an issue that there is no API. So that also means that it is very hard for curators to spin off their own project, because now whatever you want to do, you have to do it within the website. I cannot just call API, run the code, and basically spin off my own project and try to build business model on top of it, and monetize myself, right? As long as there is no API, there would be very hyper fancies for curators to spin off their own independent projects. Because otherwise, you would have to build the whole tech stack yourself, run the nodes, process the data, transform it, and then query again. And finally, just a general comment about metrics in cryptosphere. Among broadly reported metrics, there is only, I believe, 2, prices and TVL. And TVL is just nearly not enough to understand the protocol fundamentals and what's actually happening. It's often a misleading metric. So it's very hard for everybody to navigate the space when we also don't have a very broad reported metrics, right? So beginning of this year, being aware of these problems, we decided also to back one of the emerging data analytics platforms Footprint Analytics after talking to them for more than 4 months, and they deliver, right? They already support 17 chains, full data access. They are working on pre-processing the table to enable it to be much easier to query for the end user. They are building tools to allow also curation for the people that don't have coding background. And they already have API support, right? So we just currently focus on NFTs only, but soon it will provide full access to the Footprint dashboard. So these are some of the reasons why we decided to back Footprint. Another area that I feel it's probably the most interesting one is how to make data composable. So at the moment, the trusted Web3 services, centralized one Web3 analytics platform are just not compatible with Web3 vision, right? In order to, even for some of the Web3 native solutions, there is no guarantee that the data that you are reading is actually tamper-proof. It happened to me a few times to read, let's say, again, the graph is amazing, but it happened to me a few times to read the data from some subgraph and find errors, right? There is no guarantee once you read the data that this would be accurate data, right? So in order, there are some prerequisites to have this composability. So the first thing is that it has to be built on the premise of trustless and tamper-proof, right? So it's a complex problem to solve, but I cannot just imagine like smart contracts managing billions of dollars in their vaults, like integrating some centralized API to be like sensitive to the data that's happening, right? So I feel this is like creating this tamper-proof data. I believe there is a clear demand, and I believe that this can lead to like next generation like dApps, because currently smart contracts are to some extent limited in terms of like resources and what they can provide, right? Like there is no way to be like sensitive to the on-chain environment and like to react based on the data. And I think with this tamper-proof data, what we will see, like a general trend that we will see is like minimizing the human governance and maximizing the reliance on algorithm. And this would be possible only if tamper-proof data source exists. So in this area, we were fortunate enough to meet Space and Time. They're like amazing company. They're working on this tamper-proof data, like their first decentralized data warehouse and on-chain analytics. And they built something they define as proof of SQL. So it's like a novel cryptographic primitive that sort of ensures that once you read the data, that this data is immutable and like trustless. So this then opens up opportunity for smart contracts to read this data and like not to add like additional security assumptions because of reading this additional data. This was not possible before, right? Kyve network, right? Also one of our recent investments. I think problem statement here is similar in an extent that they're also trying to address the problem of not having like a layer that validates the data, right? Like they're more focused on the storage solution, and they're part of like an Arviv ecosystem. We are generally bullish on Arviv ecosystem and investor in Arviv token, and believe that this permanent storage narrative is becoming, that everybody is becoming like increasingly aware about this permanent storage narrative. We think that Kyve could become like a go-to app for developers that want to store their data on top of Kyve, right? They already have market recognition working with several notable layer ones on helping them standardize, validate, and store their data. I think one interesting way to think about it is also, let's say in the future, if Ethereum community accepts this, adopts this like state expiry, right? Like to make it like more scalable and easy to run the nodes. So then they would have to do something with this like archive data, right? Like, and this would be very sensitive data that needs validation, and you also want to ensure that this data is available forever. So we think that Kyve and Arviv are in great position to dominate this like storage narrative. Decentralized identity. So yeah, we mentioned at the beginning, like whatever, who we are in the Web3 space will be defined by the data we generate. Like, so in this area, we invested in, like our first investment was Project Galaxy. It was, I think, like 18 months ago, something like that. So Project Galaxy was the first project that was issuing these like on-chain credentials. And now they're one of the most popular tools for other projects to engage with. Like they recently did Odyssey for Arbitrum, right? That was very successful in terms of like raising the interest, but obviously they had to pause it for some other reasons. We also have like many portfolio projects that use Project Galaxy, and the thing is the traction before and after using Project Galaxy, like the difference is just astonishing. So they're really one of the most popular tools when it comes to on-chain credentials. Another one, CyberConnect, they are building like this social graph, right? So this is, when we talk about user ownership, like we can think of CyberConnect. So what happens, right? Like in Web 2, I assume you all have like Twitter account, like everybody in crypto is on Twitter, right? And some of you might have like thousands of followers over there, which is kind of a network that you value. But at the end of the day, you are not the one controlling this network. Like you cannot just, because you disagree with Twitter policy or like you don't find the features interesting enough, you cannot just go to another platform because your network stays with the Twitter, right? So they control the network, it's not you. What Social Graph is doing is basically the goal is in Web3 first to create the network which is like on-chain, right? So you have this on-chain network that will stay there forever, right? And then applications are being on top of that, so it's not vice versa. And then what we will have over here, like potentially, like these Web3 social media companies that are much more sensitive to the user feedback, because at this time, like, they are not the one controlling the network. Like, they have to be very sensitive to the feedback, and they have to create like best products for the users. Their mode becomes much smaller, right? But the users get control over the data, and they get much more control and flexibility to move, right? Sysmo, right? Like another DID project, but that is also combining it with privacy. So I believe also most of you have like multiple on-chain wallets, right? It's probably not just one that you're using. If you think about like decentralized identity becoming like a key part of like also the way you interact with communities and like use some DeFi protocols, the problem is that you have like fragmented data across like multiple wallets. With Sysmo, actually, you can aggregate this data, and you can do it in a very private way. You can also access some of the token-gated communities without revealing or doxing like completely your financial history, right? You can just prove that you satisfy the terms without like revealing everything. After all, like, we also all appreciate to have some privacy regarding like our personal financial history whatsoever, right? So I think that in general, tamper-proof data, decentralized identity, social graph, and privacy are some of the most interesting like innovations in the space that we have seen like over the past 18 months, and are yet to be sort of like utilized to the full extent over the period over the course of the next few years. So we were very fortunate to be able to back some of these companies, and we plan to be also very active during the bear market. So if you guys are working on a data-related project, feel free to hit us up. Like, I'll be here for the rest of the afternoon, so feel free to come say hi. And with that, I would like to close this presentation and open up for another speaker. Yeah, thanks a lot.
Thanks, Momir. So now we'll welcome our dear speakers to give their speeches. So today we will have three main chapters. Their data storage, on-chain indexing and analytics, and also on-chain credentials. So after each speech, we'll have 5 minutes for Q&A. Okay, so let's get started. So Momir already mentioned Kyve, right? So I can't wait to hear Fabian to share more about Kyve. Okay. Yeah, welcome.
Thank you so much for having me. Full screen?
Yeah.
And then for the demo, should just ask you then again.
Okay.
Look at that. It's perfect. All right. Well, welcome everyone. My name is Fabian. I am the co-founder and CEO of Kyve Network. We're talk today about validating data in Web3. I'm a software developer, and I think I got into the crypto space in around quite early in 2020 probably, and then from there on I was always active in the Arweave ecosystem, and then in February last year we created Kyve Network. So basically this talk, we're just going to quickly talk about what is Kyve, what are the problems we're solving. We're going to deep dive a little bit deeper into it with a small demo, and then just some quickly overview about like our roadmap and what has been happening, and at the end just a quick Q&A session if there are any additional questions coming up. So one of the fundamental problems in the data space right now is basically that in a blockchain, data is very condensed, right? And especially on Ethereum as an example, there is no native way to query all data, for example, that lives on Uniswap. Right? You'd have to go through all transactions, find them. You can query events more easily, but in general, it's a big problem, right? And when you go even multi-chain, it gets even harder. And then how do you start connecting data from one chain with another, cross-chain bridges, right? It really gets more and more tricky because just the data is so much deep into the system because we have to optimize for data storage. I think if you guys are here some smart contract developers, you know it really has become a state of the art, right? To make your smart contracts as storage efficient as possible. Well, why? Well, because you want to make sure that the whole system stays very scalable. And so that's also the reason why, for example, NFT metadata is not stored on chain. It's only for gas fees. I mean, no one wants to pay $10,000, for example, minting. Well, some people do, but not the average person, right? Wants to basically put that much money in just to have something on chain. And this is how storage solutions like Arweave came up. And yeah, another big problem are basically that then backups or snapshots of chains right now are mostly centralized and by this not reliable. Mostly talking here about node syncs, where if you're a node operator and you would like to join a new network which is already existing, what you have to do is you have to get either sync your node, but this takes months right now, if not even years, and it's going to just take ages. But what you usually do is you get yourself a snapshot that has been done by another node operator, so you need to trust him, and then basically get this backup into your system. And then from there on, you're able, right, to run your node, bootstrap it, and make it accessible faster. And now the big question is, well, if we live in a completely trustless world, you cannot trust another node to get your data in. And we see this kind of thing happening a lot now. We're operating the Cosmos ecosystem, and we had the FMOS relaunch, right? Where what happened is they had a state failure, and then they had no way to back up their old state because they didn't store it on chain, and the new state was invalidated. So it was a big question for them, how do they go forward? And that's also something we are working on with Kyve. Another problem that's especially due to the Arweave ecosystem is there is no way to cache state transitioned. And what this means on Arweave, smart contracts are executed client-side, which means that every time you want to get the latest state of a contract, your client has to go through every state. And of course, now think about millions or billions of transactions. It's just not something your client really can do for basically on an everyday basis. And so this is also something we have built Kyve for. And then just in general, the cost of distribution for storage is expensive. The more decentralized your network is, and the more data you accumulate, you need to really ensure that every node has at least most or all of the data. And then what's going to happen is, well, you pay more money, right, for maintaining your data storage infrastructure. And then the more money you pay, the lower your profit margin on running your node gets. And then at the end, it's only the big players that can basically afford having those crazy expensive infrastructures because they are the ones that still make a lot of profit with it. So at the end, it really leads to centralization if you're not careful with that on your network. And a big prominent example of this is actually Solana, where the Solana Foundation is one of the only, I know, public endpoints out there where you're able to get the full history of Solana because all other nodes have to delete their data after, I think on Serum it's like 7 days or something like that, just because otherwise it would be way too expensive for them to really handle all the history data access. And so basically this is the reason why we have built Kyve, and Kyve is a fully decentralized data lake. And the cool thing is that all the data that's stored through Kyve on Arweave is completely trustless. And we work with numerous L1s and other solutions out there. And the way it works, it's quite a nice concept. So we have a thing called a storage pool. And then basically the storage pool reads the data from one source and then validates it and then stores it on Arweave. And I can give a very nice example. So let's say we would archive Polkadot. So the storage pool for Polkadot would request Polkadot, hey, please give me block number 5. The node would get it, upload it to Arweave, and then propose to the other nodes in the network, hey, here is this piece of data, can you please check if it's true? And then the other nodes pull down the piece of data, run some validation logic against it. For example, well, does my local block is the same one than the block that the uploader has uploaded? If it's correct, they vote in favor of it, and if it's incorrect, they vote against it. And of course, if some data is found to be invalid, then the nodes get slashed, so no one is incentivized to ever upload invalid data. And then we only keep all valid votes on chain, basically meaning you have a backtrace, then you can really find all the validated data from a data source. And the data source can literally be anything. We're talking about blockchain archives, talking about financial data, because it's basically like an Oracle system, right? Just think about the Euro to USD pricing data and how many accounting databases this lives all around the world, right? But basically here, we can just save it in a single place because it's trustless, anyone is able to retrieve it, and then you can run analytics on it, you can make it available through indexes, you can make it cross-chain through services like Excella, and so on and so on. So I hope we can dive into a quick demo here, and I can show you what it looks like in practice. And let's hope the demo gods are on my side as well. Amazing. Thank you so much. So this right here is Kyve Network's page. We're right now in our testnet. We have an incentivized testnet running since April. And it's just some basic dashboard where you can see some bundles that got created, the total value log chart that unfortunately through an update got a bit wrecked, but it's still having all the correct data in there. And then here you can see we have those storage pools. There we go. Where we are archiving all those blockchains. Right here you can see the progress. So on Moonbeam we are already up at live data. Live data meaning that we have a maximum delay of 2 minutes. Well, just because the data has to be produced, right? It has to be sent to our nodes have to validate it. So whenever you work with Kyve, you will always have, right now, a delay of up to 2 minutes. So when we click on it, here, you can see an overview. You see how many Kyve got logged, how much data we archived, how much bundles got created. And then here in the validator section, you see the nodes, basically their API. So it's a proof of stake system also on the chain level and on the protocol level. So you can delegate your tokens, stake your tokens, and let this secure the network. And actually here in the overview, which is quite nice, you see the live position of that bundle, if it got created, when the voting is ended, if this one is going to time out or not. And basically, yeah, we have a bunch of storage pools for all the, there we go, for all the different networks we support right now. Writing your integration is something that a developer can just do on the spot. We basically provide a library from our side, and the only thing you would have to provide from the counterparty is one function where you describe how to fetch blocks or data and how to validate it. So our built-in validation function is just a hash function saying, well, does my uploaded data equal my local data? But let's say on pricing information, you might fetch from different exchanges, so the price will not be 100% equal. So you can write your own validation function, making sure that the data is like almost the same, and so on and so on. So we try to make it really customizable. And then we also have fully decentralized network, meaning that all of our decisions are happening through our governance proposals. So if you would like to create a pool or create your own runtime, change network parameters, you can just submit a proposal and the community will vote on that. The Kyve chain logic lives on the Cosmos SDK chain. We've actually been through quite some tech odyssey. So we started out being fully Arweave based and then realized actually Arweave smart contracts aren't production ready enough to the extent that we needed them. Then we transitioned over being an EVM based contract, storing the data on Arweave. And then we went into this really nice EVM problem where it was during the bull market and just gas prices were crazy expensive, right? Because you have to share the block space with all other applications living on Ethereum. And that's really leading to the problem that, well, on Uniswap, if you make a 10K profit swap, you're fine with paying $300 in gas, right? But not every transaction on Kyve really has this economic value. So we had to find out a different solution for solving that. And even we deployed it on Moonbeam actually, and even there we were facing those problems. And then what we did in, I think February, we migrated the logic over into a Cosmos-based SDK, and is running quite successful, quite good as of right now. And yeah, we are going to hopefully launch our mainnet beginning of Q4 this year. So this is the incentivized testnet. It was separated in 2 phases. One phase was very social-driven, and the other one was very tech-driven. We tried to kind of really include everyone in our community. And I think at the end right now, we're ending up with 71, maybe 80,000 active users. Let's see. 0, nice. All right, that's the demo gods I talked about. I think it's around 70 or 80,000 users we had being active on the chain, but active users including users that really like delegated, staked, ran a node and so on. Oh, there we go. Unique users, nodes running 2,000, basically mean we have 2,000 nodes running in total on that. And yeah, let me just jump back into the presentation. Is it on here? Yes. Perfect. And then awesome. Yeah, as I said, Kyve actually started as a bounty project. I think it was me and John just browsing through Gitcoin one day and then sawing a bounty from Parity and Arweave, which was, well, please find a solution that archives Polkadot on Arweave. And we're, oh, that sounds like a cool weekend project. So we got started on this and then got some very cool feedback from Parity, from the Arweave community, and then we started reaching out to, well, all the other layer ones, so like Cosmos, Avalanche, Near, Solana in the beginning, the graph as well for indexing purposes. This is how the whole Kyve project got seeded in the beginning and how we got started. Then, as I said, we've been through quite the tech journey with different testnets on Arweave, on Moonbeam, and now finally settling on Cosmos. And now really the next big step is just preparing everything for mainnet. We're going to launch some bug bounty program, some feature program to really just kind of like drive that, building out some new use cases and really like fine-tuning our governance processes. And then hopefully if everything goes smooth, as I said, the mainnet launch beginning of Q4 this year. As already said, those are some of the partners we have already integrated with, all of them facing their own problems, but most of them facing the same problem at its core level. Just to go over some above, so on Avalanche, a nice use case we have there is a node operator actually syncing his state through Kyve on Arweave, and then being able, in case of failure, just go to Kyve and load the data in from there. On Solana, I already said we are archiving them. But Solana it's a big challenge even for us coming up. But basically on Solana, it's just that they produce so much data and they've really kind of like trouble providing the infrastructure for it being able to query it. And they only like, maybe now like 2 years old at max, and like it's already starting to facing scalability problems. So that's something we try to do, because once we have archived block 0 from Solana on Kyve, they can safely delete it. Because you always know you can always safely retrieve block 0 in case anything goes wrong. You can load it into your indexing system. It just gives you more flexibility. And then for stacks, we actually built with them. I think since they launched, we had an integration up and running with them for archiving purposes. And then also now with all the Cosmos ecosystems and all the EVM ecosystems coming in, we also announced a little sub-project called Warp. And Warp is a GraphQL indexer on top of Kyve. You can go to warp.kyve.network if you want to see what it looks like. And it basically allows you to query data cross-chain, right? Because we have all this data stored, and we know what the data looks like when we store it. So basically what you can do, you have one endpoint, you can put in your address, and you can say, well, what does this and this address has made on, for example, Avalanche and Ethereum? This is how you will get your results for it. It's very useful for like any cross-chain interactions you have. And just last, I want to jump into a quick Q&A session if there are any questions coming up. I'm also available all day if there's anything else.
So you're not doing anything with like custom indexing or custom processing of events, like if I'm making a subgraph. This is just purely indexing the data from different chains. Is that correct?
Exactly. So we are just purely storing and validating this data. And if you're building like an indexing service, right, you wouldn't have to worry about how do I run my full node, how do I connect to my archival node. You can really just go to Kyve, get the data into your system once, and you're good to go, right? Actually, I saw also Quill on the presentation before that. Actually, Quill is an SQL service that also uses Kyve data and then gives SQL access basically to developers that would like to get SQL access to data that's usually not available in that form. Exactly.
And maybe a follow-up question on the last point you made. So does that mean when, because you mentioned that Kyve is essentially a data lake for this data, index data. So does that mean that I can use like just RPC to get that data, or is there like a REST API that I can fetch the data with?
So there is, so basically the way it works is that we on-chain store the reference to the data being stored on permanent storage, so on Arweave, right? But there, of course, it's compressed. So what you would do is you would request our REST API at Kyve and just say, hey, either give me all valid bundles from this chain and you can fetch them on your own, right? Or we also have like one indexed endpoint we can say, oh, please give me the block height, and then we point you to the right Arweave transaction where the data is in. But of course, you would have to do all the like decoupling and like aggregation, whatever, on your own. And that's why we really kind of like see now use cases being built on top of Kyve that make this querying easier for you, right? And then that's also, I didn't think I skipped over that part a bit too fast. We have a funding mechanism for a pool. So a pool always requires funding. And if a pool would run out of funding, it would pause and not produce or archive any more data, right? This is the main incentive mechanism behind Kyve. So let's say you want to build an indexing solution that uses Kyve data, then of course you would be always incentivized, right, to keep the pool in funding and ensuring that the data that we produce is then stored in your system. That's the main idea behind it.
Any other questions? Okay. Thanks, Fabian.
Thank you.
Thanks for the wonderful speech and the demo presenting. Okay. All right. Then we'll start our next chapter. It's on indexing and analytics. And we'll have Camelia from the Graph to share her insights here. Is Kamala here? Ah, okay. Hi. Yeah.
Should we give people a few minutes to get a drink and sit down, or should I just start with that? It's fine. They will come. Okay. Great. Okay, I see a few people went to go get a drink. I'm just gonna entertain you guys for like 2 minutes, so people can grab some water, come back. While I'm entertaining you, how many people have heard of the graph before? How many are familiar with the project? Just so I understand where we're coming from. Okay. Okay, so people who are familiar with the project, how many of you guys are developers that have used it? Okay, cool, so a few. Okay, great, great, great. Oh, the images aren't loading. Oh, okay, thank you. Great. Okay. Hey everybody, my name is Camila Ramos. I am Developer Relations Engineer at EdgeNode, who is a core developer of the Graph Protocol. So the Graph Protocol has 5 different core developers now, and we all work on different parts of the project, and I work at EdgeNode. So that's kind of always a point of confusion for people. They're like, do you work at the Graph? Do you work at EdgeNode? Do you work at Streaming Fast? So today I'm going to be talking about a feature in a project specifically built by Streaming Fast, which is a different core developer that was built for the Graph Protocol. So just some context there. A little bit of background around me. I have 7 years. Before I became an engineer, I was in education. I taught kids how to code for like 6 or 7 years. I studied computer science. I went like a very traditional path for engineering where I went to school, and then I started off my career doing engineering at PayPal, where I worked on the checkout experience. So when you log out, I mean, when you pay, you can see the Pay with PayPal button. That's the checkout experience. So I worked on that for a bit. So just to frame this talk, the title of this talk is Improving Indexing Performance by 100 Times. And this is all in the context of the Graph Protocol. We'll get into a little bit more about what that means. But just to set the context, I like putting this number up so people can really get an understanding and really just understand how much data is in a chain like Ethereum. So at the time of making these slides, which was like, I don't know, a week ago, this was the current block count for Ethereum. And in these blocks, you can fit about 70 or so basic transactions. And that's like wallet to wallet paying. This doesn't mean like deploying a contract. So it could be more, it could be less, but for the most part, it's this number around times this number of transactions that we have. And that's so much data. And you as a developer who's building dApps, who's building on the blockchain, if you're building your application, right, you're going to have a smart contract that stores some stuff on chain. So an example would be like if I'm building, and this is an example I use often, is if I'm building a dApp to find my biggest fans and people, I want to track who comes and watches me talk and who comes to my hackathons or something like that. I want to track it on chain. Who are the addresses that are showing up to my talks? So in my smart contract, I might have a function where when someone checks in with me or something, I execute some function that says, you know, this is their wallet address, this is the event, I don't know, this is the time, and then this is the count of events they've been to, something like that. And then over time, right, I might want to be able to say, give me all of my fans that have been to 10 talks or more, or who have been in 10 different cities with me or more, something like that. So this is all, you have this like wealth of data on the blockchain that you as a developer might be interested in at some point, especially if you're building applications. You're going to come to a point where you want to retrieve this data and display it to your users and kind of make complex queries that you can't really do manually the way it stands today. And yeah, due to the nature and the structure of a blockchain right now, there's no built-in mechanism to identify, categorize, and query for blockchain data. So if you guys have been on EtherScan or something like that, you know if you press the contract button, you can do a simple query like, I don't know, who's the holder of this specific token ID. You can get that back. Or what's the IPFS hash for this content URI. You can do very simple queries like that. But obviously, if you want to get into some of the queries that we just talked about, like, who have been to 10 cities and, I don't know, have been a member for more than a year, when you want to understand relationships between entities, when you want to do things like filtering and mapping, it's just not possible to do it manually, easily. So I'll get into it a little bit more, but there's a way to do it, right? You can do anything. We're programmers. You're going to figure it out. But the way that you would do it is you would either build your own indexer, which takes a lot of time and engineering resources, and just you as a dev or even as an engineering team, it's a really big lift. Two, for something like an NFT project or really anything, you could aggregate all of the metadata, aggregate all of these transactions manually, write some program on the client side to filter. You could do it, right? But it's not ideal. So that's where the graph kind of shines. So the graph is an indexing and query protocol that allows developers to efficiently read data from the blockchain. So the keyword here is efficiently. Like we said, there's ways to read data, there's ways to make queries, but the graph makes it really easy for developers to make these kinds of complex queries about data. So kind of a crash course here on subgraphs in the graph, because what we're going to talk about here is this is kind of the way that it's been done up until this point. And then I'm going to talk about substreams and this new feature that increases performance by 100x. So subgraphs are what we call these open APIs that you can build with the graph. And when I say open APIs, when we think of a traditional web API, it's a way for different web applications to communicate and send data back and forth, right? So this is kind of the mental model that we're using here of like, how can we grab this data from the blockchain and then send it to our dApp? So we call them subgraphs. And to build this API, a developer generates a subgraph, and you kind of just identify and work with 4 major components. So the first one is the data source. So you have to pass in a contract address or contract addresses. So in our case, in this example that we're talking about finding my superfans, I would paste in the contract address and say, this is my data source. Then we identify and we tell the subgraph what data we want to index. So for us, maybe for this example, it's like I want to index, every time this function that's, called check-in gets executed and an event is emitted. And in that event, maybe I'll expose like the wallet address, I don't know, the city, whatever I'm interested in tracking, right? Those are the things. And then in your schema, you create this model. So you say, my schema is going to be composed of a superfan, we'll call them. And the properties that a superfan will have is the wallet address, maybe the city that they're from, and then a current count of how many of my talks they've been to. So that's what I mean when we say we define the data that we want to index. And then next we define the events that we want to listen for. So, so for maybe people who aren't smart contract developers or just aren't familiar, there's this concept of events where there's kind of standard events in things like an ERC 721 contract, which is, maybe what you'd be familiar with for an NFT contract, where there's an event called transfer that gets emitted or, kind of called when a token gets minted. So when it first becomes publicly available for sale, and then every time it gets bought. So it's a way to log these changes. So you, in your subgraph, you say, okay, these are the events that I want to listen for, and these events are the mechanism to make sure that you always have the freshest data. Because if, for example, I'm tracking my superfans, 5 minutes ago, maybe there are 20 people in here, and then if 5 minutes later 10 more people come in here, what is the mechanism to make sure that I get that refresh? How do I get these 5 new people? It's through these events. So when this function executes, this event is emitted, and then it triggers resolvers, which we're going to talk about next. So resolvers are just functions that are going to execute when these events are emitted to say, okay, something happened, something changed in our state. We're going to go ahead and run this code again to update what we want to know. So, in our case, how many superfans or something like that. So that's a crash course on how to build subgraphs. And then this little visual is, I like to show it, it's helpful just for people to see. So subgraphs live just below your client application, and you use them to display data. So they're kind of the layer between your smart contract or your L1 and then your UI. And kind of the problem that we're inching closer to with each slide here is that blockchains are optimized and have been optimized, and a lot of the work and focus have been around optimizing for writes. We talk about throughput and we talk about how many transactions in block space, but really a new problem, or a problem that we're seeing emerging, is that a lot of this stuff isn't optimized for reads. And as you said, as the years go on, and as hopefully we do this forever, blockchains are on forever, there's just going to have more and more and more data available to us that right now there's not a really great way to effectively and really easily read this data. So speaking of reading data, just also a crash course on the ETL pipeline that's going to be important for the next thing we're going to talk about. Super simple. We're going to keep it really simple. So the ETL pipeline is this process that's an umbrella thing. So it's not just in blockchain. It's in traditional software. So we're taking this concept that's been around, and it's a set of processes to move data from one data source to another, into a database. So in our example, we're moving data from the blockchain into a Postgres instance. That's the way the graph works. So you don't need to know the details, just know that. We need to somehow take this data from the blockchain, put it into this instance so that then we can query for it. So the ETL pipeline is 3 steps: extract, transform, load. Just keep that in mind. And this is what we do with the graph. So the first problem that has to be addressed when we're talking about subgraphs and kind of the graph, and I would say the number one issue I've heard with people trying to use subgraphs is that if you have a really large data set, your subgraph could take a long time to sync. It could take a long time to actually like index all of these events, and it could take days or weeks even. So for some teams it wasn't a great fit because they have a lot of data, they needed like almost instant like results, and it just wasn't working for them. And the problem is for this specific case is that all of these steps in the ETL pipeline, the way it stands with the graph and with subgraphs, is they're all done in a single unit of computation in these mappings, in these transformers, in these resolvers that we talked about. You can call them transformers. So because of this, because it all happens in one unit of computation, this has to be done linearly. So when you're talking about 15 million blocks times 7 at least, times 70 at least transactions, like that's a lot to go through linearly. And computer science people in here, O of n is never good, especially when we're talking about something this big that's going to continue to grow. The second problem is that the ETL pipeline works at an isolated level, and as of now, there was no way to connect the data at the indexing layer rather than the consumer level. So what that means is you could have, maybe your dApp deployed on multiple different networks, and you're going to have to write a separate subgraph for each one because you have one on maybe Polygon, maybe on mainnet, and I don't know, maybe one on some testnet. And the issue is that you would have to rewrite all of these and kind of merge these together in your UI, right? Your user wouldn't know that there's 3 different subgraphs because you just display it however you want. But at the developer level, there's no way to connect these at a lower level. You can only connect them at the, at your client application level. The third problem is that subgraph developers would often have to rewrite code because you can imagine for anything like this open API that we're talking about, there's some steps that you always have to do. You probably always want to get someone's wallet address. You probably always want to know someone's token count. Like things that are kind of common, you would have to rewrite them a lot. And we would see that subgraph developers would often just fork other subgraphs and then try to work off there. So we noticed, okay, this is problematic. And kind of the solution that we are unveiling, or not unveiling, it came out at Graph Day maybe like a month ago, but that I'm here to talk to you guys about is our Substreams. So Substreams were created by another core developer called Streaming Fast, and they worked on the Firehose technology, if you guys are familiar with that, and they're super amazing, a super smart team, and I'm going to try to do their technology justice here. Like I said, I'm from Edge & Node, so I usually have a different focused talk, but this was really cool and important, so I wanted to kind of try to do them justice. So Substreams are fully parallelizable, infinitely composable, and highly reusable data units. These substreams are written in Rust. Everyone loves Rust. Rust is super fast, but really the key here is that they're parallelizable. So instead of having to do this indexing linearly, we're now cutting the time by a bunch because instead of having to wait for one block to finish processing to move on to the next, we can do these all in parallel. The other cool thing is that these are composable and reusable, and we'll talk about this in a bit. So going back to the problems that we kind of just talked about, the first one was about this, O of n, processing time, and it takes too long. So with Substreams, these individual modules allow a community to build higher order modules, and like we said, we'll talk about this more in a second. You'll understand what I mean when I say these modules can be parallelized because we're breaking down this entire subgraph from this kind of like linear processing to different modules that create this tree. The second solution is that these composable modules make it possible to connect the data at the indexing layer. So now you don't have to wait until your subgraphs are deployed to then try to put them together in your UI, but still have to write 3 different ones. And then finally, these modules are written and can be shared, allowing other developers to use the modules that you or other developers have made. So they kind of have this vision for like npm install, and then you can just use someone else's things. So things that are common that you are probably going to have to rewrite often, or if you're building for a very specific use case, you might have to build this thing often. You can just build it once and then reuse it multiple times. And defining modules real quick. I say the word modules, but like, what does that mean? Modules are small pieces of code running in a WebAssembly VM amidst a stream of blocks arriving from the blockchain node. So when we think of the word like streaming fast, that's their org, Substreams, it's this constant stream of data, in which I'm not going to get into the specifics here, but at the end I link really good documentation if you want to kind of learn more about how that works. And then there's two module types. And these modules, like we said, are composable, and you can kind of play with them like Legos to do the things that you want. So the first type is a map. It maps elements from one representation, initially a block, you get the entire block, which we'll talk about in a second, to a different implementation. And then the second type is a store. It stores information and specifies the merge strategy for how stored elements should be merged together. Modules have a single output that can be typed, and they inform consumers, aka the module that's going to consume the output of this, what they should expect. So you can think of this as like a stream of water or something that's like flowing downwards. It has one input and then it outputs something. It can have multiple outputs, but then the other modules that are receiving these outputs, they're meant to receive outputs from other modules. So that in that sense, they are composable, and in that way you can kind of like mix and match. You can use different modules. You can kind of build it step by step in a way that you can abstract out certain things depending on your use case, rather than kind of the monolithic linear model that we had just talked about. And then modules can also take multiple inputs like this one. But really what's cool is that with substreams, you can unlock generic substreams. So before, like I said, with the graph, you had to pass in a contract address. So if you just wanted to do kind of like a generic subgraph, like, oh, I don't know, give me all, I don't know, the average gas price for certain blocks, and kind of just want to know all the different NFTs that were traded, you would have to take the contract of all the NFTs that you wanted to be included. There's no way to be like, just give me all the NFTs, give me all of the transfer events here. You needed to define this data source. So with Substreams, you kind of unlock this ability to be more generic. So you receive the full block with Substreams, and then you as a developer, you filter out what you need or what you don't need from the block. And then finally, the output or extraction of one module becomes the input of another module, creating this effective pipeline of data flow. Okay, and then when we're talking about index performance improvement, you don't even have to read the slide. The point is, parallelized, way faster, that's just it. Not linear, composable, you can put these together, and then these modules execute independent of each other. And then when the output, so, right, this creates a dependency tree. This creates a tree of modules. Obviously, some modules are waiting for the output of other modules, but generally, this is way more parallelized than what we had before. And then, like we said, the whole subgraph is split into these smaller modules, and the whole of these modules creates this dependency module tree. So to recap, you write these in Rust. They're brand new, just dropped like a month ago or something. We're still, me myself, I'm still playing with these and doing a lot of stuff. So if you're interested in these, I would follow myself on YouTube, because that's where I post a lot of what I'm learning and what I'm working on. So I'm definitely going to be doing stuff right there. And finally, I'll leave this slide up. So I know you guys can't click these, but I'll tweet this whole presentation so that you can then click on these links. But here I have the documentation for Substreams, and then I also have building a subgraph workshop. So I think it's kind of like important just to go through the process of building a subgraph, so then you can see how it's different from using Substreams. It's kind of hard to, I would think, to conceptualize using Substreams for the first time if you don't really know the problem that it's solving, or if you haven't really run into that. So here I also have a workshop where it walks you step by step for how to develop a subgraph. And yeah, thank you.
Any questions?
Okay, I'm gonna preface this. Don't be asking me no hard questions, okay? These just came out. Okay,
How are you today? No, I wanted to ask a question about the data architecture. So the starting point was this ETL pipeline, that extracts, transforms, loads the data into Postgres. So my question is, would the graph also allow for an ELT pipeline, where you first load the raw data into the database and then you model the data afterwards? Because I imagine that like a lot of different projects they want to access the same loaded data, but they have different transformations on this data. So then I guess the compute kind of like blows up because of that.
That's a good question. I don't have the answer for you, but I'll find out. But kind of from my understanding, I think that, okay, so you still write a schema as part of this process. So I kind of want to say, I don't know, I don't want to say the wrong thing. I'll find out for you. I don't know. But I'll find out, yeah. Any other questions? Great. Oh my God, I just tell people, I'm like, don't ask me questions while I'm up here. I'm still figuring it out. But yeah, so this is by Streaming Fast. They are a really cool team. You can tweet them. They are like super helpful. They've been helping me kind of get started and like use them and play with them. You can also come to me for questions and I'll go to them in the back end, answer them. All right, thanks y'all.
Thank you. Substreams sounds really interesting. Yeah. So next we will have Mario from Solidity Network. He's going to talk about why we need real-time risk infrastructure.
Hello. Okay, hello together. The first thing I would like IOSG and the organizers for the invitation and the opportunity to talk in front of you. I will talk today about the need and the reasoning why we need a decentralized real-time risk infrastructure. Few words about me. I'm the co-founder of Solidity Network. This is the startup I will introduce today. A few words about my background. I spent more than 10 years in corporate development, working for major German corporations. From my background, I have a technical and business background, and I'm in crypto since 2016, basically following the first days of Ethereum and up until now. Has also exposure with my first startup, which I started beginning 2020. So, I believe the recent events in crypto reminded us again like how dangerous the space actually is. With the collapse of Terra Luna, there was a massive wave of liquidation triggered in itself, and it leads to consequences which we are still feeling in itself. Even the founder of FTX, Sam Bankman-Fried, warned us that some of the exchanges are still illiquid and there could be some additional problem coming in itself. This wave of liquidation led to a situation that some financial organizations like Trio Capital, Celsius, and BlockFi went insolvent. And the interesting part actually is when we look at these financial startups, most of them were actually centralized in itself. For example, BlockFi was valued last year around 5 billion, and it was sold a few months ago for 20 million to FTX. On the other side, we have the DeFi space, which was also affected by the wave of liquidations, but from the liquidity side in itself. Most of the protocols are still there, they are still working, they are doing what they are actually supposed to do. And I guess this event showed us the huge difference between centralized and decentralized entities in itself. On the one side, we have intransparent financial systems, so basically we kind of don't know what are they doing, how they generate these yields behind their products. There is lack of trust between the institutions in itself. We have the counterparty risk. we all can remind the Lehman moment we experience now in crypto. And lastly, the risk management they have, if they have one, is mostly internal, and basically we don't know what they are doing in itself. On the other side, when we look DeFi in itself, it's transparent, it's immutable, code is law, so basically everyone who has a good technical understanding can look behind the protocol, what are they doing what they should do in itself, and it leads to a different level of trust in itself. But also DeFi introduced new kind of risks in itself, and currently in the space, these fundamental risks are outsourced to the end user in itself. Looking at the DeFi space currently, I mean, we have to be honest, like we made a major progress in the last 2 years. We have amazing decentralized exchanges, lending, borrowing protocols. A lot of these yield aggregators came up, but to empower the next wave of innovation in this space, data is needed. And when I see like data, it starts with the thing that we need really a lot of data to build meaningful business models in itself. The data we currently have in the space is not trusted. What does it mean? So basically, if we find the data and even check the data, how it's behind generated in itself, we will get very, very cautious. What are we looking at the moment? Then the thing is like, of course, like making sense of this data is very hard, especially when the team where everything is on chain, there are like happening a lot of transactions, and I don't think like many people are able to do that. And lastly, building some kind of logic in a decentralized space is a just different beast of a problem than doing it a centralized way in itself. And if we don't want to end up in a wild, wild west, we have to improve on that topic in itself. Additionally, now with the bridges which comes to the space, like basically connecting, for example, the Ethereum chain with the Avalanche chain or with the Polkadot chain, additional level of risk is added to the whole space. That means basically the risk we have currently in the space is multiplied by the risk of the bridges in itself. And if we don't want to have a again a situation we had a few months, we have to think differently about risk in general. And now I'm coming to a topic of risk in itself. When we look at the current space in itself, there are some attempts to build some kind of risk assessments. Usually these risk assessments are done by the startup, by the team in itself. They have some kind of expertise, they are using it for that. These risk assessments are mostly centralized. And once this risk assessment is done, basically it should serve the whole space. Even we have like DEXs, lending borrowing protocols, and yield aggregators in itself, there should be like one fit solution which doesn't make any sense because the risk level and risk sensitivity in the whole space is different in itself. Then also when we look at the data they generate, usually these are centralized entities. That means a decentralized protocol can hardly integrate these data streams from their side. Why? Because if we have on one side a decentralized protocol, on the other side a centralized entity who generates this data, basically this centralized entity, even it tries to help around risk, is basically can be attacked and cause massive harm to the decentralized protocol itself. So basically that means, for example, one of these risk assessments just needs one data points to change, and this can have huge consequences on automated, for example, yield aggregators in itself. What do we actually need? So the first thing is like we have to go away from this risk assessment from the experts, even they are great. We have to have a more objective, data-driven way how to analyze the risk in itself. The second thing is like even these protocols are written once in with smart contracts. They are static. They are like working and operating in a dynamic environment in itself. That means the risk in itself is dynamic, and we need a real-time update around that topic in itself. Then the second part is, as I mentioned, is the risk frameworks in itself. We basically cannot have one risk framework for everything. There are many risk frameworks for different solutions in itself. Like we will have risk frameworks for lending protocols, risk frameworks for yield aggregators in itself, and the user should decide how this risk framework should look like according to their risk sensitivity in itself. And lastly, if we want to integrate these risk frameworks in the strategies of these protocols, how they operate, the whole infrastructure has to be decentralized. That means like from the point of getting the data, storing the data, computing the data, and putting the data on chain, the whole chain has to be decentralized, that a decentralized authority can trust this data stream in itself. So ladies and gentlemen, let me introduce Solidity Networks. So basically we are aiming to solve this problem. We are building customizable risk frameworks by using big data. So basically we are building objectively and quantified run risk frameworks. We are focusing from the first day on multi-chain. That means we are not only focusing on EVM, on Ethereum and EVM like chains, but also other ones. And we have a real-time feature which is important. So basically once you integrate your risk frameworks, there are constant updates, and your strategy, whatever the risk framework is used, can with that adjust their strategy, and possibly the harm can be reduced in itself. And lastly, the whole infrastructure should be like decentralized. These risk frameworks should be able to be implemented in protocols in itself, and the protocols should trust how the data is gathered, stored, and what's with the data done in itself. So, and lastly, what do we believe, like how DeFi is going to evolve over the next years? In the last 2 years, we had this speculative mania around maximizing the profit without looking at the risk. We believe this is going to change. We will go more in a direction of risk reward by using data. The second thing is like once the data layer and risk data is there, accessible, new kind of financial product can be built in the DeFi space in itself, which is at the moment needed. And lastly, we have so many of these DAOs currently in this space, and they have treasuries with massive capital in itself. But the thing is, like when we look about the data, how much of this data is actually put to work for them, like in DeFi, it's a very small proportion, and we believe this is going to change in the future in itself. And for all of these three things, we believe like risk management is going to be a major driver of innovation for the next wave of DeFi space in itself. It is not only our opinion, like from Solidity Networks, like also from relevant persons in the space, like for example from Dan from Pantera Capital, when we see how he defines basically the future of DeFi, it's based on risk in itself. So, are there any questions from your side? I'm open to answer. Alternatively, you can reach us at our Telegram group we set up, and we are more than happy to answer your questions. Yeah, looking forward.
Actually, I have one question.
Yeah.
Yes, so how this kind of real-time risk infrastructure gonna empower the maybe next generation DeFi projects? Like what new use cases or new scenario we can see?
Yeah, for example, we have now the yield aggregators as a simple case. They are basically looking at the space, looking where is the highest opportunity, and move the funds around that. The thing is, like, when we look around what is the decision making of these yield aggregators, it's basically just maximizing profit without looking at the risk in itself. That means if a yield aggregator has to decide between two opportunities, one delivers him 10%, the other one 9%, he will go for the highest one. Even the risk level are totally different in itself. And what will now happen, we will move from this maximizing profit idea to a risk reward idea, and then when we take the risk in account, the yields in itself are going to be calculated differently, and with that, they are going to be like more efficient. This is like one simple case. And we can go down in direction of credit and so on. Like if we want to build like uncollateralized solutions, we need risk frameworks. And we see risk in itself more or less as a base layer for new products in itself.
Cool. Thank you.
Yep.
Hi, I'm Brian. I'm from Self Protocol. We're actually also invested by IOSG at a very early stage. So we have a new product, which is the first bound voucher. So we're issuing bound. And so far, we worked with a few projects, and we raised around 16 millions for them by issuing bonds. So it's very comparable to the bonds that works in Web 2. So we're actually looking for a solution to be a bit more clear to assess the risk of giving out those bonds. And there are some platforms you may have heard, such as TrueFi or Maple. They're doing non-collateralized lending and borrowing, and every platform has their own mechanism how to assess the risk. So I think this is also something that we can talk about it later. To see what kind of solutions that you guys can offer.
Yeah, that sounds great. So basically, this is basically the customer groups we are looking for to empower. You have your solution, and we will just enhance your solution with our risk.
And what is your business model?
Our business model,
yeah.
So basically, like there are two parts. The first one is like the centralized part. We don't need a centralization for the entities who are fine with what they have. It's more of a SaaS business model. And the second part is like when we have risk frameworks, we are basically charging by querying itself. Basically, to get the data on chain, you have some kind of costs, and then it depends basically how much decentralization do you want. And it starts also like not only from the storage in itself, but also from the computing level. If you want to have everything on chain, do you want some parts off chain, and so on. And according to that, charging model comes out.
Okay. Okay. Thanks.
Yeah. Additional questions?
Okay. Thank you, Mario.
Thank you.
Thanks. Next, I will introduce an old friend of mine, Harsh, the creator of APNS, and he's going to talk about why Web3 communication matters.
Thank you. Can I also open YouTube for, yeah. Just ETHCC. NS and notification. Awesome. So, how do I go back? Yeah. All right, here we go, blue screen. Awesome. Hey everyone, this is Harsh from Ethereum Push Notification Service, EPNS for short. I'm here to talk about communication and why it matters. We are going to go through this in 4 phases, the what and the why. Then we are going to do Web3 Notif in 10 minutes or less. At least that's the thing I promise most of the people. Then we are going to look at what is the future and do a little Q&A. So let's get started. Okay, the what and the why. Before that, we have a little video for you. So I'm just going to try and play it out. I don't know how Windows became so complex all of a sudden, but yeah. This one. Yes. Awesome. So I'm going to go back, and I'm so sorry I'm calling you again and again. But yeah, those are only 1 out of 10 videos. All right, so...
What are you doing today?
Okay, so today we're
What are
talking
the-
to
what's the
EPNS,
problem we are
Ethereum Push
solving?
Notification Service.
solving
It's another incredible team from India that have been building for a while now. They're a simple product. They send you push notifications from decentralized apps, just like you would get a push notification from an Uber app if you request an Uber or if you order food. It's incredibly simple and elegant product for decentralized finance. The cool part is they got recognized by the Ethereum community early on. They got funded on Gitcoin. They crowdfunded their first round of $17,000.
Oh, nice.
And that's pretty cool. You know, they are from your neck of the woods,
Yeah, from Andheri East.
from the very east. They had no connections really. They just got into crypto with a good idea, posted it online, and raised money. And now they're expanding and hiring. And I'm very excited about what they can do. And maybe they're the next big team to come out of India. Just as a disclaimer, you know, Tanmay and I are very tiny investors in this protocol. We like the team. We want to support them. But of course,
This is not a call for you to go buy push tokens, which is, the EPNS tokens. They're called push tokens. Please don't go and buy it. This is definitely not a signal for you to do that. However, EPNS is listed on our job board, the Super Pump job board that's there. You can go work at EPNS. They have an opening. You should go check out the job board. The link is in the description. They're building something super interesting, a decentralized communications layer. That's a super important part of, it's going to be a super important part of the DeFi ecosystem is what we think. And we're excited to see the interview. All right, Akshay, we're here today with the founders of EPNS, which is Ethereum Push Notification Service. Right? Harsh, Richa, welcome to the show. How are you guys doing?
Thanks for having us, Tanmay.
Hey, Tanmay. Yeah, doing good.
hey guys,
Okay, so I'm gonna try and explain what EPNS is. Okay, and
Go for it,
you
Tanmay.
all will be very, very impressed with me. Right? So currently on our phones, the way push notifications are sent is they come through the protocol set by Google and Apple. Right?
These are some of the problems with NFTs that basically can be eliminated if we just have a communication layer that enables talking directly to the wallet address. And that's what we kind of do. Some other examples are metaverses. Like, just think about it. In metaverse, what we need to do is, we all agree future is metaverse. But what we lack is the communication behind that future. So what we do is, or recently what Decentralized did was, they organized a metaverse party, but they had a Zoom call. And that was because, again, there was no communication layer that was built for Web3. And that meant there was no way we can communicate to wallet address that are users. Same thing with DeFi, same thing with DAO. If you're a DAO participant, what do you need? You basically need to be informed of the proposals that are coming to you. And your username needs to be informed, which is wallet address, but that doesn't happen. What happens is a very indirect, broken communication, which is people coming to Discord and saying that, hey, this proposal might be out. And that causes problem. Like, first of all, you don't get to know that a lot of proposals are coming. Second of all, we have seen Discords can be spoofed. And there is no way to verify that you are actually the community holder. So yeah, that's the problem with DAOs. When you come to DeFi, the problem intensifies. Like, we haven't seen anyone going out on a holiday and coming back, and the bank is saying that we couldn't reach out to you, we didn't know who you were, so we just foreclosed your bank, your house. But yeah, when you come to DeFi, your loans, they get liquidated, and as a wallet address, you are not able to know about it. So all of this is because there's no communication layer that was made to ensure that a wallet to wallet can communicate with each other, can notify each other. And that's where we come in. What we did, well, we basically created a decentralized communication layer that enables any dApp, any smart contract, or any backend to send notifications that are tied to wallet addresses. And these notifications or communications can be sent gaslessly, can be sent in a multi-chain way, and can be sent in an open network. What it enables is, for the first time, crypto wallets can now just tap into this open network and can say that, please send me all the notifications or all the chats that are happening for a wallet address like 0xA or 0xB or Vitalik.eth. And now we have a way for all the notifications to basically make its way from a service provider, from a protocol to a wallet. And that's what EPNS basically solves. So yeah, how to Web3 notif in 10 minutes or less. This was a workshop, so I would probably just talk over it, like how it really operates. So the way this protocol works is like you have, if you are a third-party protocol, you come to our protocol and you create a channel. That basically means that you are setting up few activation flags and you're setting up some governance control on our smart contract. And once you do that, after that, you can just send notifications out, either targeted notification, encrypted notification out to a particular user, or you can send it out in a broadcasted way, or you can send it out as a subset. Of course, when you are sending these notifications out, as I said, a smart contract can send it, as well as any dApp and backend. And the way this technology works is, like, if you're sending it from a dApp and backend, what you're doing is you're signing these notifications with EIP 712 and sending it to push nodes. The push nodes essentially are validator nodes that basically listen to these communications. They index it out if everything looks good. And after that, any crypto wallet can just listen to the network and can just tap into the notifications. One of the important things to remember is that because we are multi-chain, so notifications can essentially be sent from any EVM, non-EVM, or even non-Ethereum based blockchains. I'm talking about Solana. So yeah, so what's the future? As I said, like, notifications, they are just a start. An Ethereum user, I mean, our vision is that an Ethereum user would be able to send notifications or communications or chat to Solana user. A Solana service can send notifications that can land to your MetaMask or your Trust wallet or any other crypto wallet. So yeah, we are just getting started in building this communication primitive out. Once notifications are done, you can do so much more things. For example, and here's the alpha drop, we are coming out with wallet-to-wallet chat very, very soon, which includes notifications as well. So for the first time, you will have a Web3 equivalent of WhatsApp, wherein you can send notifications or messages to different users. And not only that, because this is content-independent chats, you can send so much more. You can send images, videos, but you can also submit an improvement proposal, and you can even send transactions, or you can say, hey, let's just split the bill. And because this interface supports, or because the interface is content independent, it just listens on the JSON payload and adopts to it. Because of that, it will let you do all of these things. So yeah, that's about EPNS. The workshop didn't happen, but you can easily go to YouTube and you can find some of our workshops. We recently did a workshop at ETH Amsterdam as well as at New York. These are some build ideas in case you want to go through it. I'll just give the slide a couple of seconds. All right. Awesome. And I think we can do Q&A now. go for it.
Hey there, thanks.
Hi.
That was really interesting. I'm wondering, sort of looking at these future projects, like what's the actual possible throughput that you could get with these things?
Got it. So the throughput, because, I mean, that's a very good question. Like the V0 of the project, it was just based on creating a smart contract middleware. And then we realized that there are a couple of problems with it. There were 3 problems with it. The first problem was the throughput was limited by the blockchain TPS. Second problem was the gas fee because we were on Ethereum. And the third problem was like a lot of protocols, like for example, we are working with Aave or ENS or Gitcoin or Polygon or, you know, MakerDAO and around 60 or 70 or so protocols. A lot of them, they said that they want to send notifications which are like in the amount of at least thousands, and therefore, you know, this smart contract version will not suffice. That basically made us realize that we need to create a network, and we call this like the push network. And what it does is now it's a validator set of nodes, kind of like the graph, that basically are listening to all these communications or communication payloads that are coming in. And now they listen to our smart contract, as well as they have a way to listen to any service that are directly sending the JSON payload. And because of that, the throughput becomes really, really fast, because if you're a app or a backend, you're basically just using the RESTful APIs to interact with the push nodes network, and then the node network just quickly indexes it and shares it out. In the future versions, we'll also introduce sharding, which makes the real-time communication even faster. Awesome.
No more questions? Okay. Thank
All
you,
right.
Harsh.
Thanks.
Thank you. Thank you
Yeah.
so much.
Thanks, everyone.
Okay, then we've entered into the last chapter. It's about on-chain credentials. So we'll have my good friend Enrico from Polygon ID to talk about on-chain credentials using zero knowledge. Take it away.
Thank you, Queenie. Okay, so let me introduce myself. My name is Enrico Bottazzi. I'm technical writer for Polygon ID, and today I'm gonna introduce you the identity layer for Web3. So let's start by playing a game. This is a really boomerish meme, but I think it makes its job. So, what's your identity currently in Web 2 like? So, ask you this question. I think most probably your answer is gonna be your email address. It can be maybe your Instagram profile. It can be your Twitter profile. But does it actually represent your identity? Does it actually represent your identity in its entirety? I think the answer is no, because if we go to the root of the internet, we can say that internet was built without an identity layer in it. What does it mean? Like, if you think right now, our identity is scattered across accounts. It's not an identity. We are only accounts, and these accounts are not truly self-owned, are mostly are owned by other platforms, by centralized platforms. So how digital identity evolved through times? We started with the normal username, password, login. We moved to login with Facebook, login with Twitter, and now we got to connect with MetaMask, connect with your wallet, basically. And I mean, like, what we accomplished is really cool. Like now, we have data portability, so every time you can connect, you can bring your own assets across platforms. You don't have this burden of passwords, and you have actually ownership of data. So in the wallet, you store your own keys, and basically this gives you the possibility to prove that these data are actually owned by yourself. So which are actually these data, the identity data that we currently have in Web3? Mostly is financial transactions, is token, is assets, but like right now we can see even like at ETHCC everyone was exchanging POAPs using ENS names. So we are kind of trying to express our identity in a, let's say, more personalized way. So we are adding things to express our identity on Web3, on our wallet. And this is cool, but like, if we want to achieve systems that rely on better coordination, better access control, of course, this is not enough. I mean, this is just like positive reputation, but of course, there are many other things that make for our identity. It can be our address, like home address. It can be our tastes, our friends, the places that we like to visit, that we are traveling to. And of course, we don't want to put such data on chain. We don't want to put him publicly visible on chain. What we need, so we need a self-sovereign identity that fully represents yourself while also adding privacy. So we want to retain what we already achieved with Web3 wallet, and we want to add two things: more data, basically, and the second thing is to add a wall of privacy between our public identity and this data. Just making a quick step back, how an identity model looks like. There are three actors involved. There's an issuer, which is someone that says something about you. There's you as an identity holder, and there's a verifier, which is basically every actor that wants to know something about you. And of course, there must be trust between verifier and the issuer. So as a verifier, I need to check information issued by someone that I trust. So if it's not clear, maybe this will make it more clear. The COVID certificate example. So the COVID certificate is something that is issued to a government, and every time that you want to, I don't know, travel or go to a restaurant, at least a few months ago, you had to scan this QR code. There are a few problems in this model. So first of all, every time that this QR code gets scanned, basically the government receives a call and to give access to this information. And this is bad because the government is going to be able to track all of your the travel, the places that you visit, the restaurant that you go to. And the second bad thing is that the verifier will be able to access not only the fact that you are vaccinated, but other personal information, such as your name, your country of residence, your date of birth, and it's something that is not needed. So how this structure can be improved by adding privacy? We can add privacy by making the issuer not being able to track your identity, not to track your movement, not to track your interaction. We want to make the identity holder to be able to share the minimum possible amount of data to a verifier, and we want the verifier to be able, starting from this small amount of data, to be confident about the validity of the information that gets shared. So now we move to an example that is more close to our space. Is a proof of concept that we developed, and it involves Polygon DAO. Basically, the idea here is to use Polygon ID identity layer to create CB resistant mechanism, but based on privacy. So the idea is that Polygon DAO is able to verify that a person is actually an individual without giving up any privacy of that individual. So without accessing any personal information, without requiring any authentication, basically. So how this process works? First of all, someone has to create their identity by downloading Polygon ID app. It's a wallet, basically, but it's not like similar to MetaMask wallet. First difference is that it stores a different key pair. So it's not your Ethereum key pair, but it's a key pair called Baby Jab Jab that is more friendly with ZK Snark circuits. And the second thing, the most important role of the wallet is that it stores the claim. It stores all of your identity information locally on your wallet. So the issuer, in this case, is Polygon Verify. After an identity submits their document, their ID, issues claims to the wallet. These claims are, for example, your date of birth, your country of residence, and your proof of personhood, for example. And at the same time, the issuer adds this new claim as a leaf inside of an identity Merkle tree, and the root of this Merkle tree gets published on chain. So here, I think the thing that we need to underline is that starting from the state, the root that is stored on chain, is impossible to fetch any information about the claims that are stored inside the tree. So now it comes into place verifier, Polygon DAO. Polygon DAO makes a query to identity holder. In this case, the query is, are you part of Polygon DAO? Are you actually an individual part of Polygon DAO? This query gets received by the wallet, and the wallet, starting from the claim stored inside the wallet, locally generates a cryptographic proof based on the query asked by Polygon DAO. So Polygon DAO receives the proof, and it has to verify the proof. The verification happens starting from the root that is stored on chain. So Polygon DAO is now confident that the claim of the identity holder is valid, is not revoked, and was actually issued by Polygon Verify. So the cool thing here is that the identity holder never discloses any personal information to the Verify. It's only sharing a cryptographic proof that doesn't say anything more than just the fact that it's queried by Polygon DAO. Okay, so now let's see it in practice. Let's see the demo, if it works. Okay. So on the right, you see Polygon ID app. Basically, the first step is to initiate your own identity on the wallet. As you can see now on the right, it's empty. There are no claims inside of it. Now, from the wallet, you are connected to Polygon Verify that is going to issue you some claims. So right now, you are authenticating. You are going to share your ID. So after the ID is verified by Polygon Verify, this is going to generate claims that now the wallet is going to fetch and receive inside their wallet. So we can see we have 4 claims: proof of personhood, Polygon DAO member, date of birth, and country of residence. Okay, so the claims are being added to the wallet. And now we see we have 4 claims. As I said previously, proof of personhood is just saying that you are an actual individual. Polygon DAO membership is certifying your membership to the DAO. Date of birth, of course, certifying your date of birth, and country of residence, certifying your country of residence. So now it comes the cool part, actually. So you're going to use this claim to vote for a Polygon DAO proposal. On the left, you see Grail, which is a platform to vote, to cast your vote. And now, actually, I wanted to pause for a second to point you to this thing. So it's not like the traditional connect your wallet experience that like you connect with MetaMask and then the platform is accessing all your on-chain history, all your tokens, all your NFT. Basically, this connect your wallet means just authenticating and sharing your public identifier. No other information is shared with the platform. Then it's going to the proposal. As you can see, there is a Polygon DAO proposal which is actually live. And in order to submit your proposal, to submit your vote, sorry, you have to prove eligibility. On the right, you can see the request. So it's asking you to demonstrate that you are a Polygon DAO member. And if you submit your proof, basically, you're now locally generating a cryptographic proof that to prove actually your eligibility to vote for this proposal. So the proof is generated, you're now able to cast your vote, and no personal information, nothing about your claim is exposed to Grail, which is the voting platform. So okay, just two more things that I didn't mention in the structure that are cool is the claims reusability. So it means that we now use the claims issued by Polygon, by ourselves, basically, to authenticate into Polygon DAO. But like these claims can be reused across any other platform. So any of you can decide to get the access to their DAO, to their platform, according to the claims that are issued by someone else. And another point is that the attestation is permissionless and can also be peer-to-peer. So everyone must be able to create their own claim. It also doesn't need to be like corporate subject or business subject, but it can also be myself issuing you claim that you attended this event potentially. So you can think about how rich this wallet, how many data points, identity related data points you can add to your wallet. And to finish, I just wanted to mention a few use cases that you can implement using Polygon ID. You can, for example, in DeFi, you can add on-chain private KYC. You can create decentralized credit score. You can, in the realm of Web3 social, you can create portable reputation across platforms. You can create anonymous credential-based posting. So for example, you can potentially prove that you are part of a DAO, but publish in an anonymous way. And lastly, in DAO, as we see, you can create CB-resistant voting mechanism, reputation-based voting mechanism, and the most simple one, just private gating access. But the thing is that starting from this infrastructure, as you can see, both the claims and the query are a completely, let's say, broad and open data structure that can be composed one of each other. So if you think about any current application that lives and it's based on identity, using this Polygon ID identity layer, you can basically improve any mechanism, any coordination. So last thing, I want to invite you to build on Polygon ID. You can see two QR codes here. On the left, you can find the next hackathons. They're gonna include Polygon ID as bounties. And on the right, you can see the docs that are being built. It's like temporary docs, the initial infrastructure of Polygon ID that you can start using to basically either issue claims or on the other side, get access to your platform based on privacy-based verification. Thank you. Of course, if you have any question, feel free to ask.
Is it possible today to add a verifier of a specific claim on a smart contract?
Yes. So right now, if you check the current docs, you only see the off-chain verification. So let's say Web2 based authentication, but it's, I think, a matter of weeks when we are gonna release the on-chain verification. So yeah, you can just set up a query, and inside the smart contract, you will either get true or false as a result of the verification.
Okay, thank you, Erico.
Thank you.
Thanks for sharing. Okay. Next, we will have Hombo, founder of the bank, to share with us about user profile and on-chain credentials. So DBank is also a portfolio of IOSG Ventures. We invested in them like in 2018 or 2019, right? So it's been quite a long time. Okay, Hombo, please.
Hello everyone. Yeah, today I'm here to introduce our view about the decentralized society, and I will show that what we can provide for the decentralized society right now. The topic is about the database, the trust network for decentralized society. And right now, when we're trying to find something in this industry, we know that something like the Ethereum is a smart contract platform. It's just a code-based trust network for developers. What's the meaning of the code-based trust network for developers? It means that, okay, in this network, all of the developer can try to write their own business to a smart contract, and the smart contract will be open on the blockchain. So we are also able to read it as a third-party developer. I'm able to read it, so I will know the business model of other developers. And after that, it will be really easy for me to understand your company's business model. So it will be really easy for us to build the trust between us. So after this, that's why I think all of those DeFi protocols will be widely integrated with each other, because it's really easy for other developers to read like some Uniswap smart contract or MakerDAO smart contract or Aave smart contract. So they can easily integrate the smart contract in their own smart contract, and all of those will be worked. And also for a DBank team, we have integrated nearly 1,000 and more DeFi protocols on our portfolio tracker. Why we can do that is just because our engineers are able to read all of those smart contract blockchain. So it's really easy for us to trust them without any communication. We can just read their smart contract and we know that, okay, they do the things good. Then we will try to integrate them. So that's why I think the smart contract platform is a really, really a good code-based trust network for developers. But it's only for developers. Because in the next I will talk about, for the general user, I don't think they are able to read the smart contract. You can say that maybe for the Uniswap, right? Maybe for a general user, when I'm trying to trust the Uniswap, what should I do? To be honestly, I don't know the meaning of all those smart contracts written by the Uniswap team. So what I should do, I can't just read the smart contract directly. So I'm not able to directly to trust the developers by only reading it. So that's why I think we also need a database trust network to connect the user and the developers. In these cases, I will show that, okay, developers also write their own smart contracts, but for the general user, they can't read it. So what should we do? I think we just need a translator to help the general user to translate it, right? That's why our team will focus on to analyze all those smart contracts on the blockchain. And then we will know the business model, we will know the logic of all the smart contracts. And after that, we can generate the enough information, enough knowledge, enough data for our general user to use it. So our general user will be able to understand, okay, what will be happen after I send some transaction? What will be happen after I do something? So it's just like, I think it's just like the lawyer in the traditional world. So I mean, when we're trying to do business with some service provider, they always propose some contract for us, right? So as a general user, I also don't know the meaning of those words on the contract, but we have the lawyer. The lawyer will help us to translate it, to let me know, okay, what should I do and what the service is provided. And after that, as a general user, we are able to know all the business model, all the logic, what will be the service be. So it's how the trust works. So that's why we're trying to build the translator here. And I will show some example here. It's a screenshot of the Ruby extension wallet. It's when the user in the left side it's a screenshot about when the user trying to do some to buy some NFT on the OpenSea. You can see here, okay, we will list enough information to tell you, okay, right now you are trying to interact with the OpenSea, and the action is called blah, blah, blah. And then we will show that, okay, if you send this transaction, you will transfer maybe 12 or more Ethereum to this smart contract. And what you will be get back is 2 NFT you will be received for your own account. So that's why we call it the translator, because when we're trying to send a transaction, we know that all the information in the transaction is just raw data. Users are not able to read it. But if we are able to understand the business model of every smart contract, then we can be the translator for the for help user to understand it. We just do this on our extension wallet as this. And the right side is another example. It may be a scam website, I think. When user trying to interact on a scam website, this website won't tell user what will be happen, really, right? So in these cases, user will find that, okay, if they send the transaction, they will lose 6 NFT because the smart contract just want to transfer their the user's NFT to their own accounts. So it will be give user a warning about that, okay, maybe this website is just a scam website. I think the user shouldn't send the transaction. That's an example for help user to translate the information when they trying to send some transaction. And also, we know that a lot of service provider, their service will be continually serviced. We need to verify and monitor whether they have provided the same service as they promised on their website. So that's why we also trying to help users to track and monitor services after they sign a transaction. I mean, it's a portfolio tracker. After user deposit their token into like some Uniswap or some Aave, they will know that, okay, I will got some reward, maybe the token of Aave, maybe the token of Uni, but do they really do the service as they promised on the website? I'm not sure. So I need someone to help me to track and monitor the services they provided. It may be some scam website. Okay, after I deposit into the smart contract, maybe 1 day later, 2 days later, they will stolen my token and my token will be missed. So it will be really helpful for help user to track and monitor all the service, also after send the transaction. So after we provided all those services, we found that, okay, we really can help user to easily understand and to trust the developers, but it's not enough, because if you really want to connect the user to the trust network, you cannot only provide the service to help user to trust developers, you also need to provide the service to help user to be trusted. So that's why we're trying to find the problem here. I think users also need to be trusted in the Web3 society. So how can we do that? Maybe you will think about something like Web3 credential or on-chain credential or some DID solution. But here, we want to introduce you about the Web3 profile. We think a Web3 profile is a more native way to help user to be trusted instead of just, okay, maybe use an Oracle to help your passport information to be stored on the blockchain. I think maybe that works, but the Web3 profile will be more native. So how the Web3 profile to prove themselves? It's really easy, because user right now in the Web3 world, we will have a lot of states, a lot of information, maybe on the blockchain, maybe on the public internet. If you talk about the on-chain states for the user, I mean that, okay, it's how much token user have, how much NFT user have. It's all of those is about the on-chain state for the user Web3 accounts. It will be really helpful for the user to be trusted by another guys, maybe by a developer, maybe by another users. And also, user will send a lot of transaction on the blockchain and publish it on the blockchain. All those information, which we think is just a sunbound activity. I think it's just, we can call it a sunbound activity, because this information cannot be transferable, cannot be transferred to another Web3 account. It's only related to your to the user's own account. So it's sunbound activities, we call it. And also, user will trying to send some text. Maybe the on-chain transaction is really expensive right now. So right now, we can see that a lot of Web3 applications, they provide something like, okay, you can just send some text, and you just post this text to my application's backend, and so I will know that, okay, right now is who is interactive with my application, and what action you want to do. Maybe this off-chain and on-chain service balance, I think in the future will be much better, because on-chain transaction is always expensive. And all of those information, we combine it and provide it in a Web3 profile. Because some of the time is about your portfolio, and some of this is about your Web3 activity or Web3 history. And all of those Web3 profile will be really helpful for another guy to trust you. So I will just show some example. Oh, not this one, doesn't matter. Yeah, human readable Web3 profile can help user to gain trust. Here is the example of our website. You can see here, okay, we will show that, okay, how much asset this user have in all those Ethereum compatible blockchains. Right now, we support like 35 or 34 Ethereum compatible chain. It means that because the Web3 account is compatible in every Ethereum compatible chain, so every transaction happen on the account, you can just aggregate them as one user. So that's why we will do this for the Ethereum compatible only chains in our products. And you can see not only the total value of the user's assets, you can also see which chains he have interacted with and how much value he have saved in those chains. And also we support the NFT assets or something like, okay, is this user have ever posted any article on the Mirror? He is the Mirror author. all of those information will be really helpful to help another guy, another user, to trust this Web3 profile. And last, I think another problem for the trust is about user can just see our product. Okay, after I see this product, I will know, okay, this guy is really active on the blockchain. So I will follow him. You can say, okay, this guy has 3,000 followers, and all the TVF is about $45 million. Because I trust him, I like to follow him. A lot of users want to follow him. Then it will become a big trust machine for help users to gain trust on the Web3 world. But it not works for the developers, because we know that developers always use API to interactive, and we have the smart contract. But all of those data is just off-chain data, right? We collect the on-chain data at our backend, but after we process it, all of those data is just calculated at our own backend. It's not on-chain data. So what should we do if we want to provide the service for the developers? I think it's really easy. You can say that, okay, as a user, they have their own Web3 profile. Okay, I think as a developer, we can just try to snapshot all the Web3 users' profile at maybe one block, and then we will have some rules to filter them. Okay, maybe some guys you think he's worth your airdrop or not, right? And some guys you don't like him. And after you do this, you can just have a whitelist, and you will push the whitelist on the blockchain. So it will be really easy for your smart contract to read all the information to verify if a user is on your whitelist or not. And after that, you can do your own business logic. You want to airdrop to him, you want to you want to give him some credit, everything you can do based on this logic. And for this infrastructure, we have also opened all our Web3 profiles at our Open API. We built the Open API Web3 profile for developers. Right now, we provide two services. One is the real-time API. It means that you can request everyone's Web3 profile in the real time. Maybe it's just less than 5 seconds or 10 seconds. We will get all of those Ethereum compatible chains activity at our backend and provide the API to you. And we also provide the data snapshot service. It means that, if you really want like millions of Web3 users data portfolio snapshots, we can do this service for you every day, and we will push this data to your backend. Yeah, that's all the service we provide right now. So after that, we think all the problem for the users. The first problem we've served is about how can user to trust developer. And the second problem is about how can user to trust another user. And the last problem is about how can the user be trusted by developers. And we think after serve all those problems, we can see a whole trust network is really for the user and also the developers. Finally, provide some resource for you. It's all the information about our service, DBank, Rabi, and our Open API. And at last, there are also my personal email and Telegram. If you want to talk with me, feel free to add him. Okay.
Any questions for Hongbo?
Hey, thank you for your presentation. I have a quick question for you. Have you already seen some interesting API integrations from anyone, and like what would be the use cases which are most fascinating?
You mean use case? Okay, good. Yeah, like Coinbase, they have their own extension wallets, and they also want to show the user, how much assets you have in Maker, in Uniswap. So they have integrated our API to help their user to track their own portfolio. Yeah, they like Coinbase. And also for consensus, they have I remember I have a MetaMask institution, maybe for the institution side. They also want to provide the same service for their clients, or their clients maybe want something like, okay, how much money I have today and how much, and what is the portfolio like yesterday. So right now we also provide something like the portfolio history for the MMI side. And the other side, like the trading firm, Jump, they do a lot of trading, but they also want to know, okay, how the token is on the blockchain, how the Web3 profile looks like, how much users have this token. So they also use our service at their backend. And also Ethereum, M token, a lot of other wallets have integrated our service. Yeah, I think most of them, yeah.
Thanks for that, really interesting. I'm wondering on the kind of understanding transactions, how do you guys do that in the backend? Is it basically hard-coded and parsed, or do you do some automatic parsing of these smart contracts?
You mean to analyze all the smart contracts? Oh yeah, that's cool. Yeah, we do it for 4 years. I need to say, okay, at first, we need to do it manually. We need to manually to read every smart contract, right? After that, we will have a pattern. Every smart contract has their own business logic, right? We will have some pattern, maybe a pattern for AMM, maybe a pattern for the lending protocols, right? So after that, when the DeFi Summer coming, there are a lot of Uniswap forks. We're just trying to compare the source code with our pattern. If we found a match, then it will be automatically to be integrated on our backend. So, I mean, right now, we don't see too much innovation in this industry, right? So most of the DeFi protocols right now, I think we are just automatically integrate on our backend, yeah.
Any other questions? Okay, thank you, Hongbo. Thanks. And now we are going to have a panel to invite all our speakers here. Yeah, so we'll get it ready in 5 minutes. So yeah, so maybe you guys can take a break and get some drinks. guys, we're starting the panel. Welcome to join us. We have all the speakers here.
Okay, you mean the blockchain?
Sorry about that. Okay, guys. So yeah, we have Adrian joining us, and the other guys already introduced themselves earlier. But I believe some of you weren't here, so I guess we'll do another round of introductions. I also again introduce myself. So I'm Amir. I've been with IOSG for the past 2 years. So been mostly focused on DeFi research and investment. Also very interested in data analytics, so from that angle I have honor to host some of these amazing guests. I pretty much enjoyed their talks in this afternoon, but yeah, I'll let them say a few words about themselves. Hombo?
Yeah, Hombo from DBank, just yeah.
Hello together, Mario Radman from Solidity Networks.
Hi, I am Fabian, the co-founder of Kyve Network.
Hey, I'm Harsh from Ethereum Push Notification Service, like the Web3, native Web3 communication protocol.
And this is Sismo. We are building an attestation protocol using ZK.
Right, so to start with Hombo, so for DBank, I'm always quite impressed how fast you guys move. Originally, 2 years ago, I used DBank quite a lot for just protocol analytics, not only portfolio dashboard, right?
Got it.
But in the meantime, you kind of changed the focus, right? So now it's a smart wallet, browser wallet, right? And it seems you're also positioning now as some sort of a social middle there. So can you just take us through the evolution of DBank and your perspective, on the product, and I was always also interested why giving up on DBank swap and protocol analytics.
Okay, cool. I think your question is about our product. Maybe right now we also have 3 products. I think one product is about the DBank portfolio tracker, and one is the Rabi for help user to do the interactive on the Web3 application. It's a Chrome extension, and we also provide something like the Open API for our DBank. To be honest, as I talked before in my slide, at the first time we are trying to serve the problem, which is how can help user to be able to trust the DeFi protocols, to trust all of those smart contracts. So at that point, we have built the DeFi portfolio tracker. We have trying to build the extension wallet. So, and also some analytic dashboard, right? Like the TVL, like the DEX volume. Yeah? At that time, we're just trying to help the user to trust the DeFi protocols. But after that, we found that there are also a lot of problem for user to be trusted. So that's why we began to do something like right now we can call it Web3 social ranking. It's because we want to show the Web3 profile for another guys to show their profile for help user to be trusted. And at last, we're also trying to do the Open API. It's just because, okay, we understand that there are lots of developers in this ecosystem, and we also want help user to be trusted by those developers. So we're trying to provide all we have to those developers. Yeah. So I think it's mainly because at the first time we only found the small question about how to help user to trust smart contract, but after that we found the problem is become bigger and bigger, and our product is become bigger and bigger. Yeah.
Okay, makes sense. And why is it actually that you guys are not doing debank swap anymore? Like that one had.
It's easy to answer because the Chinese regulation is not so friendly for you to provide any swap feature to user.
But you're not in China anymore, right?
Yeah, right now I'm not in China.
so you can bring debank swap back.
Maybe, yeah, maybe.
That was my favorite tool.
Cool.
Okay, yeah. Who else? Mario, yeah. So Solidity, you also talked about it today. Like, it seems like you're approaching this risk like from very like a general perspective. Like it can be like credit risk, it can be like user risk, it can be like risk framework for like portfolio management. What will be sort of like the initial focus for Solidity, and like what sort of use cases are you guys going? Would it be like to B or like to C? Like what sort of targeting we have over there?
So basically, our focus is like risk frameworks, and we are going to target in the beginning centralized entities. And the reason for that is like we want to have by far the best risk framework out there, and centralized entities are fine with APIs in itself. So basically, the whole complexity of decentralization is not needed there, and we can optimize our risk frameworks to the best possible. And then in the second stage, we are going to decentralize, and the decentralization also mean what level decentralization is necessary for customers. There are customers who like kind of hybrid solutions, and there are customers who want hardcore decentralization, and we will provide both of them.
So initially focus on like
B2B.
Yeah.
We are a B2B company. We don't aim to go B2C. Basically, we want enhance the current startups and solutions in the market with our solution, making them better and safer.
Okay, cool. Fabian, yeah, you talked a lot about the importance of validation, but I think we also have some fresh audience over here. So we also talked a little bit about Kyve network in our presentation earlier today, and why do we find it as a critical piece of the infrastructure. But can you, again, like for those that haven't been here, like explain why do you feel that validation is such a critical piece for like RVB ecosystem in general, the whole blockchain space, right?
Yeah, absolutely. I think the big problem with validation is, I think you said it quite nicely in your presentation, when you said that you're actually using the graph but getting incorrect data sometimes, right? Because what it's going to happen is you have your decentralized network where you can be sure that everything is correctly, mathematically proven, it's valid and it's correct, but the moment you take it off this system into another system like an indexing system and so on, and the transportation gets not validated, mistakes can happen, right? Basically, you're taking away the security you had on-chain to like your off-chain tooling, and then you sit there and it could have incorrect calculations, incorrect states, and so on. So this is why we kind of like really focus on making the transportation valid and like caring about validity there, to then basically being able to then serve more valid and correct data than to your off-chain tooling, of course.
Yeah, makes sense. Also, yeah, this first question is obviously like everybody's doing something like around data, but like in very specific niche. So it's very hard to ask one question to everyone, right? But it's sort of like first question targeting like a market positioning of each of these protocols. EP&S, we know each other for now like almost 2 years, right?
Yes.
Something like that.
Yes.
At the beginning, I remember like you guys, at that time there was not much like focus on consumer experience, right? Like even today, like some of the DeFi protocols just don't care. Like for example, Curve Finance, right? Amazing UX over there. But you guys were like trying to fill in this gap like since day one, right? If I understand well and follow up with the progress, right? Like currently you are also positioning as like more like a generic computation, like a communication layer P2P, right? So considering that you've been here like for already 2 years, which is a veteran for the crypto space, right? Like how do you like think about EP&S like 2 years ago and positioning as of today?
Got it. So Momir, because this is crypto, it's not 2 years, it's 20 years. But yeah, coming back to the problem, like the problem is communication. Like we are very social. whenever we are talking to someone or whatever we are doing in our virtual life, it's every time it just boils down to communication. Like even right now we are communicating, and when you take that away, a lot of problems surface. Even or especially in the case of DeFi, like DeFi is such a huge innovation. It has the capability of going and making a global bank. That changes world. But it changes world if you are able to notify people that your loan is going to be expired. It will not change the world for good if someone comes back and they say, oh, my Ether is gone or my tokens are no more. So that was a problem statement that we had, like when we started working on this, and it was a very personal problem for me, more so because I lost in loan liquidations a lot. So that kind of led to the idea that what happens if you bring the usability and UX of Web 2 to Web 3. And all of a sudden, if you do that, you basically are able to get that adoption that we all want. Like innovation, they basically get you early users, they get you tech enthusiasts. But adoption only comes when the barrier or when the technology is invisible. Like no one cares that we are talking on FaceTime via WebRTC protocol. What they care is that they open up their phone and you have something which can facilitate that. No one cares like how WhatsApp works. What they care about is that when their friends send them a message, they are able to deliver. And that's the same thing which led us to EPNS, and that's the same thing which led us to communication. Now, when we started working on it, we started with notifications because not many people realize, but everything we do is around notification. Even WhatsApp chat is notification, even FaceTime call is notification. And that's why EPNS focused on notification first to make sure that it's decentralized, it's Web3, and then work on more critical components like chat and in the future video call as well. So that's the grand plan or the grand vision of EPNS, to be the de facto layer, not just for Ethereum, but for Web3 as a whole.
And you feel that like for push notifications, is it like priority to decentralize this? Because at the end of the day, like the end users are notified, right? It's not going to be communicated to smart contracts that manage like billions of dollars. Like these end users are not going to take automatic action based on like a certain notification. Do you feel that for push notification protocol, like decentralization, like is an important narrative, or like you feel that like being centralized for this sort of service is also fine?
Got it. So actually, it will not work in the centralized space because what centralized notification does is that it ties your data to that particular app, like Facebook knows your data and they will do notifications. But when you are coming to Web3, everything is shared. We have a shared username. That's our wallet address. And therefore, these notifications had to be decentralized because the vision is that crypto wallets, they can trust these notifications because it's trustless, and they can show the users these notifications in the future, therefore improving the UX a lot. It's very much like how Ethereum does it or any other blockchain does it, where the data is decentralized, so any front end can just tap into the data, can just trust the data, and the user owns the data, but at the same time can interact with it everywhere. So that's the reason why Web3 needs a decentralized communication layer rather than a service, because why would you trust a service on Web3 when Web3 is made like to be trustless and to be decentralized?
Okay, makes sense. Adrian, yeah, you are the only one that didn't have time to come to be a speaker today, right? So feel free to take a bit more time, right? So yeah, Sismo, like we are also obviously biased. We are one of the investors in Sismo, and earlier today we also mentioned you guys and the thesis for investing. But maybe for the rest of the audience, like it seems that this privacy narrative has been in the space like for years, right? But it somehow like it still didn't like take off, right? Like why do you think now is the sort of like a good timing to build sort of like privacy solutions in Web3?
Yeah, actually maybe we can start like just before privacy, tell a bit about the state of all what we do. There is more and more on-chain data. Users own more and more data. But think that, and these guys are making it available for us or more dynamic. So from this data today, we don't leverage it really. Like I usually have my wallet on this blockchain, this one on that one. Even on the same blockchain, sometimes I have my DeFi wallet that is private. I have my professional wallet on which I receive my salaries from a DAOs. I have my contribution wallets, and there's no way to share data. Like the fact that these wallets, like we don't benefit from the fact that I have actually access to an aggregated reputation. In the end, I own the keys of all my wallets, and so I should be able to have an aggregated view of all my reputation, all my history, and be able to use it in applications. For instance, there could be DeFi protocol that use reputation for interest rate computation. And so now when you think about that, like, what does it mean if your DeFi app uses your social reputation? Currently, it would mean that you would link your DeFi wallet with your social wallet, and this is things that we don't want to do. And if you take a look at the current applications, you have DeFi applications, you have governance applications, you have airdrops. Like, there's no link because everyone has different identities, and they don't want to link them together. So this is where privacy is very important. And in Web2, it didn't take off because Web2 is centralized. They don't want to create bridges. But in Web3, we actually can make bridges, right? We have control of our data. We can connect all of this together. But we need privacy so that you don't link your banking account with your social account. So that's why I think that privacy matters, because now we have access to our data, and only users should have the aggregated view. But when they communicate to external apps, they should just reveal what they need. If I need to prove that I'm a Ether holder, I don't need to prove that I have this specific address with all my history. So that's the whole reasoning why I think it's a great timing for privacy.
Yeah, makes sense. I think this is to some extent relevant also to Solidity, Mario, right? Like we also brainstormed recently about like the possibility to do like risk framers to analyze the user credit rating, right? Like this is very related. Like credit rating is also part of your DID to some extent. It's just about like analyzing this data and having these models, right? But in order to support some of these, like to integrate with smart contracts to support this sort of like so it doesn't even have to be under collateralized borrowing. It can just be like non-uniform borrowing, in a sense that you, based on your credit rating, you can receive, like you can have different interest rate, like what you mentioned, like based on the identity, or you can have like different collateralization requirements, right? But for Solidity, like to be able to serve these use cases, right, like it would have to sort of like find a way to decentralize like their tech stack, right? So how do you think about approaching these use cases and like decentralizing Solidity tech stack?
The thing is like when we do decentralization, someone has to pay for that. This is the first thing, and because decentralization is 1,000 times more extensive from the computation and storage level than a centralized solution. And then the question is like how to make it smart that it works. For, let's say, like risk framework is easy because one risk framework can be used by many protocols, and the bundling of the costs can work with that to get the costs down. For user-specific data in itself, the question is like how big is the add-on in itself, and this goes actually in the risk calculation inside or in the opportunity in itself of the uncollateralized loans in itself. And for us, it's like one part is like addressing the part trustworthy to the person, and the second part is like risk sensitivity, what we're also getting out of it through the trading history of the wallet, of the identity. We can also see his behavior in the past, and through our unique solutions like volatility index, we can see how he behaves through different volatility times, and with that we can get this information, provide like strategies, what investment can be done. About the topic, what you are asking for a user, like about decentralization of the whole infrastructure. I would say like we can make everything 100% decentralized. This is not a problem. The thing is like it's going to be like more expensive. It will be slower in itself. But the question is like, does everything has to be decentralized? Can we make some part off-chain calculation and some part on-chain? Do we have to have storage 100% decentralized, or can we use immutable databases who are centralized? I believe these questions will define a lot the computation power we are building our solution and the cost in itself. And what we learned from the space currently, not many of the protocols are decentralized. They are aiming, it's marketing, but they are far away from real decentralization. Maybe this is going to change. But on the other side, what we also learned, there are a lot of new projects who are building like next generation of these projects what we have, and they are hardcore fanatical about decentralization. So what is going to be like in 2 years? Solidity Network doesn't know, but will provide both solutions.
But if you go for like a decentralized use case, I assume like you would also have to have like a open source database, like open source, because there are two parts of the protocol. First, like data, and the second one, like machine learning models that analyze this data and produce some like risk metric, right?
Yeah.
Do both of these need to be like open source, and if they are open source, like where is the moat, right? Like is it in data itself, or is it in machine learning models then?
I believe in the beginning, like the value is in data, because data is not available, and this is the prerequisite for everything. Once the data availability is there, machine learning is going to play a major role. How do you build it? What does it mean efficiency? What does it mean decentralization? And so on. But this is the second stage. For us, like, I mean, the question is like, how much data do you take for the calculation, for the risk framework in combination with decentralization? We believe not necessarily everything has to be open. You basically have to ensure everything which is written in the database is unchangeable, and you have to ensure that data you got is validated and in the right way stored there. And in the end, our customers will care about the risk and not about one specific parameter, but he has to have the opportunity or be able to double check what kind of data was used, how it's stored, and so on.
Okay, makes sense. Hombo? So like few months ago, I think I read like in Chinese news that you guys are going to do like a debank chain. But like few days ago when I was thinking about this panel, I couldn't find anything about it, right? Like, and like in like there is no English version about the document. Like so. Is this like still plan, and like if it is, like why there is a need like for you to decentralize data stack, and what would it mostly be just for storing the data that are you currently storing in centralized servers, or what would be like the role of this debank chain?
Yeah, got that. We still talk with a lot of layer 2 teams to find the final solution. I can't say right now, but we will have a chain for debank, but it won't be for all of those data on the debank, because you know that most of the data we provided for user is something like if we talk about your portfolio, right? It will be changed every second, right? Maybe the token price will be changed. Maybe you will do any action to change your value, right? So those data is not so stable and not so valuable. I mean, so we won't store everything on the blockchain. But
isn't that like what Ceramic is trying to address, like storing this sort of data that is mutable?
Yeah, so something like, okay, I mean, I think in this industry, trust is the value, right? So we help the user to gain a lot of trust. Like, okay, some of guys on our platform now, they will have 20,000 and more followers. The follower means that I follow you, and means that, okay, I trust you. I trust you means there are a lot of value here. So in our opinion, we think, okay, the follower relationship should be stored on the blockchain, because its value belongs to the user. She should own this value by ourselves. So we will try to identify which, okay, maybe some of the data is the high value and maybe immutable, and we will try to store it on the chain. But if something is just, okay, not so valuable and always update, we won't do it on the blockchain, yeah.
And you mentioned like you're looking at L2 solutions.
Yeah.
Recently, everybody's going to Cosmos. It seems like. What do you think? Like
Cosmos?
What do you think? Like, I personally feel like L2 app-specific rollups are much better than Cosmos, like app-specific chain. But I was curious. What do you think about it? Because you said like you're looking for rollups, right?
Yeah. We are trying to looking for some rollup solution because in my understand, if I choose the Cosmos, I also need to do the consensus layer. We need lots of validator here, right?
Security
so the security is based on our validator. I don't think it's not valuable, but it just we don't want to care about those things. We want to focus on our products, focus on our user, and focus on our data. So that's why I think we will more prefer to choose a layer 2 solution because the security is based on the layer 1, right? So we don't need to care too much about the validator, the security, yeah.
I agree. I feel it would be like waste of resources if now every application goes out there and like tries to spend ton of inflation in the token just to like ensure some sort of security. Like I agree that like it's better focus on the niche like you are performing. If somebody else is like offering the best security, like use it, right?
Another problem is if you want to base on Cosmos, it means that you need to issue a token. Then you will get the validator, right? But for a team which don't want to issue a token so early, we need to choose the layer 2.
It's not early. You're already in the space for 4 years.
Yeah, I missed for 4 years.
It's time for token. Yeah, Fabian. Fabian, like, from what I understand, like you guys ensure this like validation by increasing the redundancy, right? Like it's sort of like maybe easy. It's how blockchains work. Like it's all about increasing redundancy. Can you just like explain like how and why like everybody should trust like Kyve that once they claim it's validated that it's actually there is no room for error?
Yeah, absolutely. So actually Kyve itself, we don't create redundancy in the data. That's what we use our permanent storage layer for, like Arweave, or in theory you support other networks as well, but we focus on Arweave right now. And of course on Arweave you then create the redundancy in the data, so you are sure that once you store the piece of data, but that's true for all on Arweave, right? You know you can always access this piece of data, like it's permanently stored. Kind of like why Kyve basically is trustless is because we have created a fully decentralized network of nodes, right, using this voting mechanism and then ensuring that the data is valid, right? So because we are linking basically the vote result with the Arweave transaction on our chain, right, we always know that this piece of data that's stored on Arweave permanently is going to be correct from our network, basically.
Makes sense. And do you guys, like we had also the graph presentation today, like, and I think you also briefly touched on the graph, right? Like, so would you say, what's wrong with the microphone? Would you say that Kyve is like sort of like complementary to the graph, or like, or you guys like are replacing, taking out like their share as well, like doing indexing and everything like yourself?
That's actually a question I get quite a lot, like what's your guys' relationship with the graph? And actually it is a very complementary one, because basically what we do is we are collecting all this data for them passively anyways, right? So what they can do, even with the new Substream feature announced just at the talk, right? It's super powerful because instead of pointing their like Substream system to nodes, which you have to spin up in the network, right, where you have to like pay continuous money for, they can just point them to Kyve and just get them in from there. And because the Substream framework is quite generic and super easy to work with, right, you can now start to write substreams and build subgraphs even for non-EVM solutions, right? Because we have non-EVM data, we have like NFT metadata, financing data, and it's just like that, right? You just write a substream, you get it into your subgraph, and you can query for it. So it's very complementary on that level, I would say.
Okay. Adrian, in Sysmo, right? Like who is actually like doing attestation in Sysmo protocol, and like are these entities like also have to be decentralized, or like how to think about this question?
Yeah, I think that there's two ways to create attestations. The first one is you are a centralized issuer and you sign a message basically. This is if you know about verifiable credentials, it's a bit like it works. It works like that. Like it's a central party sign a message that says this data is true and I'm the authenticator. In the case of Sysmo, what we try to push is user-generated attestations. So precisely, what we're allowed to do is, let's imagine the list of DAO voters in ENS. Users put the data in their browser of all ENS voters. They generate a proof that they are part of this group. So that's how the attestation is created with ZK. They generate themselves the proof that they are a ENS voter. And then this ZK proof is sent on-chain and verified by a smart contract that then issues the attestation and the ZK badge. That is the NFT representation of the attestation. So just want to say that here the attestations are user-generated, trustless in a way. So there's not that much trust in this kind of attestations.
Okay, makes sense. Yeah, this one was complicated.
Yeah.
Well, let's have one simple one. Like, how can like some of the DeFi and NFT projects like integrate with Sysmo? And like, do you already have like partnership with some of them? And like, how do you see maybe like Sysmo ecosystem like 5 years from now? Like,
actually it's pretty simple. If you want to, you have reputation in 2 places, and you want to extract your reputation to use it somewhere else, you can do that. For instance, I don't know if you know about Lens protocol, but it's a social media. They might have some issues with civil resistance. They might be like bots or stuff like that. Many projects have this kind of issue. There are a lot of, on the other side, there are a lot of proof of humanity projects or civil resistance projects that are able to create attestation of humanity. And these attestation might be linked to the real name. With Sysmo, you can really just take your doxed proof of humanity and send it to a social network like Lens without revealing your human. You just reveal that you are a human, but not which human you are. And generally, whenever you need to bring data from a place to another without doxing yourself, that's where you will have some nice use cases. Like
makes
again,
sense.
yeah, in governance. I can go long, but maybe not. No.
Feel free.
No, another thing that I think is very concrete is governance. For now, we vote with tokens, with financial capital, and we would like to vote with reputation, but we don't want to link again our financial wallet with our social wallet, and so that's why we don't see proof of usage or proof of participation in governance in some voting. So that's also something that is very interesting.
Okay, makes sense. Harsh, like, how do you guys like think about privacy? Like, if you are building like P2P messaging protocol, like there is this, like first blockchains, everything is transparent, right? But then like messaging, communication, everybody wants to keep it private. Like, how to balance this, and what sort of like architecture needs to be kept on-chain versus off-chain, like for the messaging protocol?
Got it. So this is like a really awesome question. There are 2 ways by which we envision this to happen. Like the first way is like you are a wallet and you have your blockchain data, and now the protocol is communicating to you about things that are going on in the blockchain, which can be your ENS domain expiry, or it can be your DeFi loan liquidations. In that case, the communication can be plain and simple, and it's already on the blockchain, so it doesn't matter much. Coming to the other part, like the part when you are chatting, or the part where protocols need to send you messages or even encrypted transactions, at that point of time, we leverage something that we call like dynamic encryption or encryption independent content, which basically means that for now, the encryption we have, they operate on the public and private key of the user. But because we wanted to keep it like way future forward, So the way encryption occurs is that it's always assigned a type. And as we move in the future and as we see like better encryptions coming up, like there's one which we are developing for chat, which is PGP plus the private key of the user. So that way what happens is like the content is encrypted by the public key of the user, or the PGP key is encrypted by the public key of the user. But because it's an asymmetric encryption, only the private key of the user can extract the PGP key out. So you can still send communications out which are open, which can be tapped into any other crypto wallet, but only if you are a user of your wallet and only if you are able to prove the ownership will you be able to extract the content out. So that's like one of the ways by which we are approaching encryption. At the same time, we know that encryption levels or encryption standard, they keep on changing every 4 to 5 years, and that's why we have this content independent thing cooked into it.
And what are sort of like unique opportunities that can be unlocked by like a decentralized communication protocol versus like a centralized encrypted like messaging protocol? Like do you see like any unique use cases like coming out of this, and like why would this like be important, for like example, for someone who is using WhatsApp on a daily basis and everything is encrypted, right? Like how do you think about this question?
Got it. So actually the simple answer is we just have to look in the past. Like if this was true, then after email, nothing should have been invented, because why go to WhatsApp when you can do something on email, and why go to Twitter when you can do something on WhatsApp? The thing is, like, we usually operate in a way with the identity of the platform. So in Web3, the identity becomes a wallet address. So now either you basically go for a very indirect communication wherein the wallet address would say that this is my WhatsApp number, and then you message it out. But most of the time, or all of the time, the much cleaner approach is that your username is your wallet address, so you just send communication directly to them. So that's one of the points why it's important. The other point is, like, unlike Web2, Web3 is shared. Like, you have shared username. I use the same wallet address for Aave, then I use the same wallet address for ENS, for Gitcoin, and so on and so forth. Because of that, the data is shared between the dApps, and therefore the communication also needs to be shared between the dApps. Otherwise, how will a crypto wallet tap into your wallet and say that these are the communications for you? Because your username is not changing between dApps to dApps. So you need a way by which you can tap all the data and can show it out.
Makes sense. And also, like, I would assume that this sort of like messaging protocol would be composable with like finance applications on chain, right? It would be composable with everything else that's built on chain. So for example, you would probably just be able to type text and send money like to someone within like just with the P2P exchange, right?
Exactly, exactly. So the way this protocol is built, it's built to be super flexible, because that's a communication protocol. You need to be super flexible. It's built to send any data, whether it's on-chain, whether it's off-chain. It basically depends on the user or the protocol, what they want to send. And that's why we introduced this content independentness, which basically means that the JSON payload defines what the data will be and how it will look and how it will interact, therefore making it more robust and opening more use cases in the future. Like in the future, we see even OTP coming from on-chain or a Web3 solution. Like, it might not be on-chain, but we think that it will be a Web3 solution. And even if that happens, the protocol is designed to adapt into that. In fact, one of the cool things that we are working on the protocol right now is about governance. So right now, governance, they lack. I mean, it suffers from voter apathy, which means that the voter doesn't know why the proposal is important. And at the same time, we are expecting users to open their desktop, even if they know that a proposal is coming, connect to their wallet, then go and vote it out. And EPNS just makes it super easy, because now we will have, or very soon we'll have a notification type wherein these governance proposals can come directly to your Chrome extension or mobile app, with a yes and no button. And you just have to say yes and no, and that's about it. So that's how we are envisioning how the process and UX and UI will evolve in the future.
Makes sense. Hombo, I think you had one question from the audience today about like who are the users of like DBank API, right? And most of them are like centralized in a sense, like services, right? Now that you build like DBank chain, I assume like you envision also some sort of like new like use cases and potentially like even in the decentralized world that can be built on top of like a DBank data stack. If so, what sort of like use cases are you thinking about?
Yeah, just as I said before, we are focused on the trust problem, right? So we help user to trust DeFi protocol, and we also help user to trust user. So when we're trying to open our data, the first client will be all those wallets. So that's why something like Coinbase, MetaMask institution, like some Ethereum or other wallets, are trying to integrate our API because they also need to help their user to track and monitor their own assets here. But in the future, I think maybe in this industry, maybe every application, they will become a separate wallet by themselves, because you know that, okay, if you want to deliver a mobile application, I mean, maybe everyone needs to have their own wallet solution, and they also need to help users to track and monitor all their assets. So I mean, maybe every application will be focused on the different scenario. Maybe some of them will focus on the NFT trading, some of them will focus on the DeFi, or some of them will focus on the social. So, but everyone have to help users to track their own assets here. They need to help users to manage their token. So what I mean about, okay, our API can be widely used when our ecosystem going to be spared to focus on the different scenario. They will need the basic layer of data. And the second layer, I think, we also help users to build their own Web3 profile to help them to be trusted by other users. So that's why right now lots of social applications, they're also talking with us, okay, can you share a lot of data can I share a lot of data to them, help them? Because you know that if we want to do a social, it means that at first I need to trust you, right? I need to know who you are. I need to what you have to do on the blockchain. So in these cases, our data will be fully match these needs. They will use data to help another user to understand, okay, who you are talking with, right? So this is the second, I think the second scenario who is talking with us at most. Personally, I don't find other big scenario. That's wallets and some social applications, yeah, right now.
But the thing is, like you guys are also in sort of like a social graph, right?
Yeah, we provide infrastructure. I mean, yeah, we provide infrastructure to help user to trust another guy. But we also have a follower relationship.
Right.
We're also trying to open it on the blockchain for other developers to use it. Yeah.
Okay. Fabian, you talked about main clients of Kyve like being like layer ones, right? And it seems it's mostly like for archiving like the data so they can reduce the burden on nodes. I was actually very surprised. I think you mentioned Solana is archiving data in like every 7 days or so, right? Besides layer ones, like do you see demand from like what are the data types like that have demand for validating data and like storing it on Arviv through Kyve, obviously?
Yeah, actually it can be any kind of data where you would see there's some need for decentralization. So even here at the conference, I met super interesting people, one working with climate data, right? And they have this open data set of climate data. And they were thinking about, well, how can we start decentralizing that data and then making it available like for other people, basically just like turning data that's just privately available into a public good, right? Because it should be a public good. And that's actually some use cases. I saw a big use case, just finance data, like an Oracle, right? You can quite easily build an Oracle with Kyve and then just have all the data basically being stored there. You can start and get Web 2 data import it into Web3 by using Kyve, because we can connect to any API. We can connect to the European Central Bank Euro to USD pricing information, right? And we can just take this on-chain once and then, I don't know, through Excel, through the graph or whatever, make this available to the whole ecosystem. Because I would say it's a really rich kind of like way we can deliver data. It really depends on the use case you have. Or NFT metadata is, for example, also like a big thing, right? Store this on Kyve, on Aave through Kyve, and then basically you can use this metadata wherever you want. It's not reliable in S3 or somewhere else. I would say that's like the big use cases we have coming up on this like non-archival process.
Makes sense. And yeah, maybe one more final question, right? Like I think we are wrapping up. So you're obviously all like very smart guys, like, but you all have like limited time, right? So if you could clone yourself, like what would be like important problem in the data space that you feel like it's necessary to address at this point of time? Like, what do you think are still like the missing pieces in the data space? Like, probably this is a question that is general and everybody can answer. So maybe we start from Adrian and go this way.
Yeah, I think that there should be more data liquidity, ability to share data from a wallet to another wallet.
Sharing data
from a DID from a wallet, from a blockchain or another blockchain or from two wallets. Okay. And data should be liquid.
Okay.
Assets are liquid today, but data is not liquid.
So let's say you think that, for example, if you own two wallets, or like if me and you share some data, or is it like just me controlling my multiple wallets on chain?
Like it's more the simple fact that if I want to prove to you that I'm a holder of any token, let's say ENS, today I must share my wallet to you.
You mean EPNS?
Yeah, EPNS, of course. But yeah, there's no solution today to share my data with consent and with respect to my privacy. And our brains are not ready to understand how important it is, because we've been raised with Web2 accounts, and Web2 companies don't want to share their data. They are walled garden. But this is no longer the case. So we should make the data liquid, create apps that take data from all your identities everywhere. And I think that some of us are all working on this.
All right. So the first 5 clones probably on EPNS, but maybe the sixth one. Sixth one can work on solving more UI UX problem. Like I genuinely believe like we all are working on some very new and very groundbreaking things. But for us to get the users, we need to solve a lot of things. Like even for example, I was listening to this talk by ChainSafe, and they were saying something as basic as when we speed up transaction from a crypto wallet, the dApp doesn't know about it and the interface is broken. And it's very easy to adjust that if the dApp can just talk back to, or the crypto wallet can just talk back to the dApp. So I would say I would put probably my clones on UI UX, because that's something which I feel we can do in a much better way than Web2 if we put our heads on. So yeah, 6-1, though.
Sure. For me, it would be actually better data oracles. So having a better access to data from a read perspective. Awesome. So basically better and more reliable access to data. I think we talked about this here with some people here already. It's like there's such a crazy demand of getting data into your system, working with your data, figuring out like the data points you need from this very rich data ecosystem. And to be honest, right now, the whole data oracle layer is very, very insecure. We saw with the Terra crash and Chainlink, right, where suddenly DEXs were trading Terra at 10 cents because Chainlink didn't know how to put with the oracle, so they put this like stop thing in there. We had suddenly incorrect data in a completely like, we would think decentralized system, right? And it happens basically all the time. You said it on the graph, right? Like whoever builds some application, runs a DEX on it, we are all running into some big risks. And I saw some oracles out there that claim to be, well, like real-time oracles, but they validate the data after it's stored permanently. I'm asking myself, well, all right, then someone stores some incorrect data, I use it in my application, I do some completely incorrect risk management, incorrect pricing information, whatever, and then afterwards they can claim, oh yeah, this was incorrect, right? That's really not kind of what we should aim for. We should really aim for like data being as reliable as possible. I think we've done quite a good job on the storage side of things, and now it's really about kind of like the getting it out of storage and getting it into the application side of things.
I like actually your answer about oracles, especially as we basically see oracles as one of the risk factors, and you would be surprised when you see like what you're getting from Chainlink. From the topic, what would I do if I don't do on if I wouldn't work on Solidity? Like there are two topics which are extremely interesting, but it's not the focus of Solidity. The first thing is like storage in combination with zero knowledge. Basically to enable decentralized storage, but using zero knowledge proofs to secure the privacy of the data. I believe it's a huge topic. It's kind of complicated topic in itself. And the second part is like doing machine learning, but federated machine learning concepts, because I believe they can like reduce the cost drastically if done reasonably good.
Honestly, if I can clone myself, I won't do something about the data. What I really want to do, I think, is about we really think about the Web3 application security problem at the front end source code. You know, right now, I think most of the team is just focused on to audit their smart contracts code at most time, but the front end security also have a lot of problem, I think, because a lot of hacker maybe hack your front-end code and he can easily just transfer users' money to another address. So I think this problem right now is become bigger and bigger because the ecosystem has become bigger and bigger, but just no one so care about it. So if I personally can clone myself, I will focus on this problem, yeah.
Momer, I would actually like the answer from you as well. If you like to clone yourself, what will you work on?
Done deal. Yeah, I think that's it for today. Yeah, thanks a lot for the time. I guess for taking the afternoon. Oh, we have also questions, right? Okay, let me first thank them. Yeah, thanks a lot for taking the time, for taking the whole afternoon to spend here with us. And yeah, let's give one more chance to audience. I think he already has a few questions. Any questions for the guests? Yeah, okay, then yeah, that's it. Thanks a lot again. Yeah, we will be around for few more, yeah, socializing for about 1 more hour. So feel free to reach out if you want to chat. Yeah, thanks a lot for coming.
Guys.
Yeah.
Yeah.
Shall we take a picture together?
Yes.
Huddling at this. Like a football team.
Okay, thank you. Thank you, guys.
Thank you, Quinn.
Thank you.
You're so sweet.
Thank you. Nice to meet you.
Thanks for having me.
Sixth clone.